Hey, I'm Darius, and I'm a developer community engineer at Mux. And we migrated 50,000 lines of code to React Server Components. And I'm here to tell you that it's possible, and not that scary, and probably worth it. More specifically, I want to tell you what we moved to Server Components, how you can migrate your own code, and some advanced patterns you can use along the way. I'm hoping this talk will be helpful for folks who are already familiar with React Server Components and are trying to understand what a migration looks like. If you want to learn more about the fundamentals, I'm sure we have some amazing talks at the conference. I also have a blog post you can find on mux.com that's almost as good as Josh Kamo's. In the past year, both our documentation website and our marketing website underwent some foundational changes. The documentation site saw an information hierarchy rethink, and our marketing website was entirely rebranded. Since these projects were under the hood anyway, we realized we had an opportunity to move to React Server Components and the app directory. For us, the benefits were clear. The app router offered its powerful layouts paradigm that meshed well with our new information architecture. And across the board, we saw how React Server Components could reduce our bundle size, improve perceptual performance with streaming, and allow us to localize data fetching with individual components. But if those are the benefits, what are the costs? How much work did it take to migrate 50,000 lines of code to React Server Components? Honestly, with the right patterns, not that much. Let's talk about those patterns. I know it's easy to feel overwhelmed by React Server Components. Believe me, we were there too. But I think our 3-step program can help with that. Here's how it looks. First, add the use client directive to the root of each page. Next, move the directive as low in the rendering tree as you can. And finally, if performance issues arise, adopt advanced patterns. Let's take a look at a few examples. So let's say you're following the App Router Incremental Adoption Guide. You have a simple page here in the Pages router, and following the instructions, you move it up to the App Router, rename it to page.tsx, and yeah. The first thing you'll notice is we've got an error. This error happens because, by default, everything imported in the app router is a server component. And server components don't have access to client functionality like use effect. Let's get rid of that error by adding use client to the root of this page. And the error is gone. But what happens if you have server-side data fetching in, for example, get static props? You can't do that on the client. So let's do this slightly differently. When we move this route up to the app router, let's move it just as a client component. And then let's import that component in page.tsx. Page.tsx is running on the server, so we can just directly fetch data there. Cool. There's more to an app directory migration than just server components. Some routing hooks, how metadata works, just to name a few. But since we're focused on server components in this talk, I'll encourage you to check out the official migration guide for that story. This part's not too bad, I promise. It's just normal programming. Follow the errors, take them down one by one. I know it's hard to believe, but the most difficult part is done. For step 2, we're going to take that use client directive from the root of our page and push it down into each individual component. Let's try that now. We're going to take it out of the file, move it into player, move it into title. Looks like our application still works. Let's repeat the process one more time. Since player has no children, we're just going to remove the directive. Same goes for title. Oh, yeah, an error in player. Let's put the directive back there. Okay, looks like everything's working again. Guess what? You're done. You've moved to Next 13, you've moved your functionality to React Server Components, you've reduced your bundle size by shipping less to the client, and now all of your future work can be done with React Server Components in mind. Bye, all. No, just kidding. We've still got like 5 minutes left. You could leave it here, but you and I both know that server components can do so much more than that. So let's move on to step 3. If you notice a place in your app that's slow, maybe from a big bundle or a slow data call, then leaning into more advanced server component features might be for you. For example, when we migrated our docs, we leaned on 2 patterns to unlock deeper gains. The first was wrapping key server components in suspense to enable streaming of slow data fetches. Our whole app is statically generated, except for the changelog, which comes from a CMS. And since the sidebar requires changelog data, the sidebar layout has to wait for the CMS. By wrapping that sidebar in suspense, the rest of the app doesn't have to wait anymore. The second optimization we applied was creatively rearranging client and server components to ensure that large libraries, like our syntax highlighter Prism, stayed on the server. And speaking of creatively rearranging client and server components, let's talk about some advanced patterns that you can take home and use in your own app. Starting with unsupported libraries. You're going to run into this a lot. In fact, if you were paying attention, we already have with our player component like 3 minutes ago. But I'm going to go over it again here since it covers some useful fundamentals. Trying to use a library that's unsupported, you'll probably get this error. All you need to do is wrap it and put a use client into the wrapper. And it works. But let's remember why this works. Everything imported by a client component is a client component. That's so important, so let me say it again.
Everything imported by a client component is also a client component.
It's also shipped to the client. Why am I repeating this so much? Well, let's go on to the biggest advanced pattern. What happens if you want to mix client and server components? Take, for example, these tabs. You need client functionality to switch between the tabs to respond to the clicks and so on. But there's no need to render all these children on the client too, right? Why are we shipping all that if it's just static? But that's exactly what would happen if you did this the obvious way. Here, we're importing password and account in our client component. When we do this, password and account, despite being static content, are still rendered on the client. So if we're not allowed to import server content in client components, how do we work around this? Well, what if we imported that content from a server component instead and passed it as a prop to the client component? Because it's imported in a server context instead of a client context, it stays on the server. Put another way, it's owned by another server component. You'll sometimes hear this called the ownership tree. If it's helpful, you can think of it this way. Use client is telling your bundler that this is the client-server boundary. If that's not helpful, well, ignore the last sentence. Since we've got some time left, one last pattern. What if I want half of my component to stay on the server and the other half to be shipped to the client? This is a pattern we've used in places like our code block. We want our syntax highlighter to stay on the server since it's a big bundle, but we want some client-side interactivity, like a copy button. Well, let's split up this code block into 2 files. We've got codeblock.server and codeblock.client. They don't have to be called that, it just helps keep it straight. Here's what the server component looks like, and the server component imports the client component, passes the server content as children, and finally, so that consumers don't have to worry about implementation, we'll use the barrel file pattern, which uses an index.ts file to re-export the default export of the server component, so that if any consumers want to consume the component, all they need to do is import code block from the folder directly. And that's migration and advanced patterns. To learn more about our patterns and our own migration, check out the full blog post at mux.com. I feel like we still haven't answered the key question here, though. Should you migrate to React server components? Honestly, I don't have a great answer. I know why we migrated. We migrated because of layouts, because of streaming, because of bundle size, and because it feels like the future of React. But right now, as you can tell from our advanced patterns, the flexibility of React server components does come with complexity. If you choose to proceed with a migration, hopefully these patterns make you feel empowered to keep that complexity under control. That's all for me. Happy coding.
Aloha, everyone. My name is Cap, and I am a developer marketing manager at Sanity.io. And today for our talk, I have Grant with me. Grant, would you like to introduce yourself?
Yeah, hi, I'm Grant. I'm VP of Engineering at Formidable.
Awesome. So today we're going to talk about Sanity.io and the Next Sanity package, and also about the introduction of the app router with Next.js. So adopting the app router requires a bit of a mind shift. And today, Grant and I will be talking about using the app router and how it's impacted his business. They use Next.js and Sanity for a lot of their clients, so they're in the mix of things. So Grant, first question I have is, you're in the process of switching a lot of your current apps to app router. What would you say is the biggest quality of life benefit you've seen?
Yeah, I think two things would be server components and being able to fetch data just from within any given component allows us to co-locate our data fetching and low-level components, and nested layouts where we can just nest layouts by just dropping in a file. Also managing error and loading states within those nested layouts using just error and loading files.
So you've been migrating a lot from Next 12 to Next 13. Were there any hiccups you saw that you had to figure out, and how did you solve it?
Yeah, so early on, many libraries in the open source space just weren't quite compatible with React Server components. So libraries that would work in Next 12 in the normal pages router just wouldn't quite work in Next 13 with the app router. So there is sort of a tricky migration path there. So a big one would be like styled components was one where you would have to wrap all of your styled components into these client components and sort of opt out of React Server components. So there's some moving around that you would have to do to get that to work. Nowadays, a lot of the ecosystem has caught up, so a lot of these issues that we experienced early on are no longer as big of issues. There seems to be a lot better support across the ecosystem.
Hey, that's good to hear. So developers can now embed the Sanity Studio directly into their Next.js app using the Next Sanity package. So how has having the studio and your application's code live in one place under the app router been better for your developers and clients?
Yeah, so previously we were often seeing people deploy a separate code for their Sanity Studio and for their front end Next application. So oftentimes they would live in totally separate repos. So you're managing two separate repositories. It was hard to share code, and then you'd have separate build tooling, separate deployment processes, and then your content authors would have to go to different URLs to manage content versus like where the public site would be. So there was sort of a disjointment there that was sort of not great for both developers and for content editors. So being able to embed the Sanity Studio helps quite a bit. It alleviates pretty much all of those pain points. You can manage just the Next.js application, use its build pipeline, use just one single deployment process, and then you're just deployed on a single domain. So your editors can just go visit like /studio or whatever you want your URL to be for your Sanity Studio. I'd love to pop open my code editor and show how simple it is to actually set this up. So with App Router, I have a page. This is just a standard page in App Router. I'm just returning a Studio component out of this. And in my Studio component, it's a client component because we're going to have some client-side code that Sanity Studio is going to need to run. But there's actually a Next Studio component that Next Sanity exports. That makes it dead simple. You just drop this thing right in here, and we've got about 5 lines of code effectively to basically plop your Sanity Studio into a subroute of your Next.js application. So very little code to get this up and running in a Next.js app, and then you can just deploy this along with the rest of your Next application.
Yeah, I remember when we launched this, I was like, wait, there's got to be more. There has to be more work that I have to do.
Yeah, absolutely. And actually, line 10 is an extra piece that isn't really needed. This is just specific to this project. So really, you could probably cut out another 5 lines of code from this. Very, very pretty simple.
Right on. Yeah, it's very simple. It's very just like, here's a couple of lines. The Sanity engineers have taken care of all the hard work. So yeah, I'm glad that we have that now as a feature and that we can embed it, because having the studio live at the main URL has got to be super convenient for editors. It's now just yourwebsite.com/studio or /admin or whatever you'd like that path to be named. All right, so my next question is, how are you using Next.js revalidate tag with Sanity, and what main benefits have you seen? Could you actually show us an example of caching and revalidation between Sanity and Next that you have in a project?
Yeah, I'll show a little diagram here that shows how I think about this at a high level. So let's say we have a web page. It's got a header, a body, and a footer, each of which makes its own Sanity request to get data, and it tags each of those requests with like a deterministic tag to use for caching purposes. So this is using the server components and co-locating our data fetches. So that's all fine and dandy, but things get a little more interesting once we put this caching piece into this. So let's say we have a client, a visitor to our web page that requests the web page. It hits our Next.js server, and we're going to make those 3 fetch requests. It could be 3, it could be 1, it could be 20 requests. But each request is, before it goes to Sanity, we'll actually make a little stop at the fetch cache to see if there's cached data for the given tag that has been provided for that fetch. And if it does, you just get cached data back for that request. Otherwise, it's going to go to Sanity, it's going to get the data, and it's going to populate that cache for that given tag, and then return that data back. After the first request, the second visitor to this page is just going to get all cached data for all 3 requests or all 20 requests. And so it allows you to cache at the individual request layer there. So this is all fine and dandy, but there's this situation that should be happening regularly where you have content authors who want to change data and they want to see their content updates on the website. Like if those content changes never show up, then somebody's going to be angry.
Yeah.
So we've got to talk a little bit about on-demand invalidation. So we've got our content editor in the Sanity Studio, and they make content changes, which goes to the Sanity Content Lake, and you can configure a webhook to fire off a post request to your app server whenever content changes in your project. So you can set up a Next.js API route that receives that webhook with some information about what content changed, and you do a little bit of logic to map the information about the content change into a cache tag that you had used previously to get that content. And then you invalidate that cache tag in the fetch cache by using Next.js's revalidate tag function. So that's sort of like at a high level how I think about the caching and how you invalidate stuff when content changes. So we'll pop open a little code just to see what that looks like in practice and how the Next Sanity library actually abstracts over a lot of the hard parts of that. So I have a little helper function in this project. We're using this create client function from the Next Sanity library to create a fetch client. And I just have a little helper function that takes in some details and some tags, some cache tags. And then it just uses this Sanity client and passes through the tags into our Next.js fetch cache options that's made available by Next Sanity. So this is a way we can basically pass through our cache tags and let the client basically tag our fetch requests. So if we go look at a usage of this, I have a get post data function that is fetching blog post data. And we've got a query and we're passing through some tags. Basically what I'm doing is using a helper here that takes the blog post slug and then generates out a cache tag for the blog post with that slug. So that's good. Now we've got the tagging of our requests done, but we still have to handle the API route for webhook handling to invalidate our cache. So I have an API route. It's a post request. And the Next Sanity library exports this parse body function that makes it really easy to basically determine whether or not it's a valid payload and then give you the information about the changed content. So it handles the security for you. All you have to do is set up a secret that's shared between Sanity and your Next app. And then you can check for whether or not it's a valid payload. I've got a lot of logic in here. I'm going to skip over most of it, but this one is basically looking to see, okay, given the content change, what is the cache tag that we need to invalidate? We're going to add that to our list of tags to invalidate. And you can add whatever sort of app logic you need around caching. But once you've collected up some tags to invalidate, you can just loop through your cache tags that you want to invalidate and run this revalidate tag function exported from Next.js.
Awesome walkthrough. And those diagrams, they helped a lot. It's been awesome to see how Formidable is using the app router in Sanity for their apps. Thanks for allowing me to pick your brain on this hot topic. It seems Formidable is finding a lot of success with the app router. Do you have any final thoughts?
Yeah, it's been great. The upgrade to App Router might be a little rocky at first, but we definitely feel it's a step in the right direction for the ecosystem as a whole.
Right on. Thanks for joining me, Grant. Thanks everyone for watching our talk, and we will see you around.
Hey everyone, welcome to Next.js Conf. I'm Sophia Andrew. I'm the co-founder and technical director of Candy Code. We're a digital agency based in San Diego that specializes in alternative brands and React websites. This talk is inspired by our agency's experience working with Next.js. React developers love Next.js for its best-in-class developer experience, but we feel like that's only half the story. By introducing more powerful primitives to the web, it empowers brands to take more control over the visual expression of their brands through their websites. And we'd love to share some of our favorite tricks to keep your website more tightly branded. Hope you enjoy. This talk assumes you're already familiar with the basics of the core Next.js APIs, so we won't be building anything from scratch. Instead, we'll be breaking apart a few pieces of our own website to highlight some of the techniques we use. But don't worry, stay tuned till the end of the talk and we'll share a link to an open source GitHub repo. It contains a README with working code snippets to show you how to use these techniques in your own projects. It also includes source code for a fun jukebox demo we've built with Next.js, Tailwind, and FrameInMotion. Let's start with typography. Type is the most fundamental building block of websites and a key opportunity for brands to express its unique visual identity. Next Font empowers brands to use custom web fonts without any of the traditional downsides. We typically supply our own local font files, but even if you're using Google Fonts, Next Font provides automatic self-hosting at build time, which means faster downloads and no network requests to Google for your users. Next Font also automatically applies the CSS size adjust property to make sure that there's zero layout shift as your fonts load in. Here, you can see how we load a local font file for use with Tailwind via the CSS variable. But by default, the font display property will be handled according to the user's web browser, which could potentially load a system font before swapping to the web font for those on slower connections. For many, this is acceptable, or even considered a best practice. But our creative director would flip if she knew anyone ever found Times New Roman on their website. So, for highly decorative web fonts, or for brands that prefer complete control over their typographic expression, you can prevent this behavior by adding the display block property. In this case, the type will be blocked until the web font fully loads the first time, which is fine because Next.js static assets load incredibly fast. Next, let's discuss imagery. In the past, heavy usage of illustration or photography meant your website would be slow for users or a burden for developers, having to maintain complicated pipelines to render image source sets. Both NextImage, all modern best practices, are baked in for free. Images are automatically resized for different viewports and converted to modern image formats like WebP and AVIF. Images are lazily loaded as they come into view with zero layout shift. Yet developers enjoy the familiar experience of working with a simple image tag. Here, in a few lines of code, we've rendered an image that will load in one of over 36 different resolutions and formats, optimized for each user's particular screen resolution and browser support. But, by default, the image will leave an empty space on the page until it fades in on load. For images above the fold, we can add the priority true prop to opt out of the lazy loading and instead preload the image. For images below the fold, we can add the placeholder and blur data URL props to show a solid color or a low resolution preview of the image before it loads. And for even more control, you can drop into the underlying getImageProps function to select different source images based on various conditions, such as light or dark mode, screen resolution, and more. This is especially helpful for art directing images where you want a closer shot on mobile, but a wider angle on desktop. Now, let's get into some more advanced patterns. And you might be thinking, what does routing have to do with my company's brand? But when complex routing behaviors are as easy to implement as making a file, Brands are empowered to deliver a unique experience to each user depending on how they're navigating your website. With parallel routes, you can simultaneously render one or more pages in the same layout. And with intercepting routes, you can render part of another route on the current layout. Both feel seamless for users and are compatible with their browser's native backwards and forwards buttons. And when combined, you can produce some really cool experiences. Here, you can see how the same route might be experienced in one of two possible ways, depending on whether the user arrived via clicking on an on-site link, which opens a modal, or an off-site link, which opens a separate page. You can see this behavior in action on our own website. When opening the modal, the route changes to candycode.com/philosophy, and when pressing the browser's back button, it closes. But if they share the route with a friend, they'll arrive on a unique layout optimized for that experience. A fun tip is to use Framer Motion's layout and layout ID props on any elements that are shared between pages. That way, they'll automatically animate polished view transitions on navigation. Finally, the power of Next.js reaches beyond your website itself. By using Next.js metadata and Next Server APIs, you can even control your brand's presence when shared on social media platforms. Here, you can see the code for generating a dynamic social media card in the style of part of our website. You may already be using distinct images for each route, but programmatically generating them goes one step further. Giving your users a preview of their on-site experience increases engagement and click-through rate. As we've seen, Next.js is a powerful tool for brands that want to express more control over their visual identity on the web. And as promised, here's a link to the Candy Code Jukebox app, which will teach you how to apply these techniques to your own Next.js websites. We hope these tips have been helpful, and we hope you enjoy the rest of the conference. This is Candy Code, signing off.
Next.js is amazing. Ooh. Does that sound convincing? Hey everybody, Trash back again at NextConf, and if you saw my talk last year about TRPC, you'll know that I love TypeScript. So much that I actually made the insane decision to build a platform for you to get better at it, typehero.dev. But we're not here to talk about that, we're here to talk about Next.js. Before we start, I want to clarify that I'm not here to tell you that the Next.js framework or the Vercel ecosystem is amazing. To be honest, you're probably watching this right now because you already feel that way, or you're just interested in the technology already. So instead of me sounding like a sales pitch, I'm going to walk you through the story of how the TypeHero team leveraged the Next.js features and the Vercel ecosystem to help us iterate extremely fast over the past couple of months. And if you find yourself in a similar situation, the hope is that this talk can guide you to make maybe similar technical decisions. Cool, that's out of the way. So let's take it back to the beginning. Let's talk about how you even decide to choose a framework before you create a site, right? So these days, there's tons of great choices. There's Next, Remix, Solid, Astro, Vue, Angular. So how do we choose? So let's consider the requirements for TypeHero. We need SEO, we need nested routes, server rendering, obviously, performance, of course, and a couple other cookie cutter requirements. And given these requirements, Next.js really stood out to me, and I'll give you a couple reasons why. I'm not going to give you this huge exhaustive list. So one big reason is Next.js is the only framework at the moment that has adopted React Server Components. And there's a feature in React Server Components that really intrigued me, and that's streaming with suspense. And TLDR of that is it's just going to allow us to have pages that display ridiculous amounts of data. It's going to allow us to display pieces of the page as that data is available, versus in today's world, you pretty much have to wait for all that data to be fetched before you display a page. The next big one is nested routes. And the ability to just use file-based routing to accomplish this easily was a huge factor for me in this decision-making.
But Trash, file-based routing, give me a config file.
Yes, I actually do agree with you there. I do love a config file. I love a nice config file, but I can't deny after trying nested routes in Next.js, it was actually pretty chill. Cool, so I made my technical decisions. We settled on Next.js. And now we actually just have to start building this. So I typically build in public almost always, whether that means Twitch, Discord, Twitter, I guess, or what have you. And it turned out a lot of people were pretty excited to work on this with me. So there's this cool visual I want to show you that I think will kind of drive the point home. So this is me. This is effectively just showing my contributions. And you can see it's just me and my buddy G, and who's TypeScript expert extraordinaire. So we're going to get to the interesting part here. We're going to get to the part where a lot of contributors join in. Any minute now. There we go. So here it's like, cool. Now all these people are contributing. Everything's exciting, right? It's pretty nuts. But to be honest, it's actually a little bit stressful. And we're going to talk about the pain points now. So as you can imagine, having all these people contribute is sure amazing. Thank you very much. But it's also very overwhelming. And as the platform grew, so did complexity, and so did the needs of the application overall. And now that we have so many contributors, I think we're like almost at 70 now, there were decisions that no longer involved just me. It was now a group of people. A great example of this would be design discussions, right? As you can imagine, discussing and let alone agreeing on anything across multiple time zones is extremely difficult. And beyond that, more pain points was, the code base is growing fast, which naturally led to longer build times. Like, who would have thought that if you wrote more code, it would take longer to build? Crazy, right? And in addition to growing pains, we also made the decision to split up our application into multiple applications. So what do all the cool kids do these days? We create monorepos. So before we go any further, let's just briefly talk about what TypeHero is. If I had to describe TypeHero in its MVP form, I would say it is like LeetCode for type challenges. So if anyone has ever done LeetCode before, you basically get an interactive editor and you just have to solve some challenge. Just in the case of TypeHero, you just have to solve a type challenge. The cool thing about this project is it's open source. So here's some of the contributors that have helped make this project a success over the past couple of months. And if you're interested in helping us or, steering our roadmap in some direction, we'd be more than happy to have you. But to tie this back to Next.js, we'll go to the core experience of what TypeHero gives you. And that's just the interactive editor with a challenge to solve. So here you can see the editor. And if you recall from my previous points of why we chose Next.js, nested routes was a big part of this. So you can see here we have descriptions, solutions, submissions, and if you look at the URL bar, you'll see that as I click around, it actually changes the URL because we want everything to be linkable. To take it even further, we actually want comments to be linkable as well. So I can actually take one of these comments here. So I'll just pick a random one, and then I'll just click that or enter that. And you can see that I can actually deep link comments, right? So you can imagine a use case for this is it's like, oh, hey, I have a cool solution and, I see your solution. I want to share it to somebody. We want that use case. So what does this look like from a code perspective? So we mentioned file-based routing. So we have this directory here, challenge, that represents this view here. And you can see we have challenge ID, which is ID is another directory that maps to this one or this part of the URL. And then we can see we have comments that maps to this part of the URL. And then we have comment ID, which maps to this part of the URL, and then so forth and so on, right? We have solutions, and we have submissions. So if I click on solutions, right, we see the URL bar change, and you can just see how easy that is. One other thing I'd like to mention is just the experience with React Server components. So this is a React component, right? I can actually embed all my server code inside the component itself. So you can see here, I'm getting server auth session, that's server code. This is actually a Prisma query. So if I look into this, open that up, we have our Prisma query here, and then I have my types for this function, and I can just share those throughout my application. So you kind of avoid the whole ceremony, like if you need API routes, or if you're using pages directory with get server-side props. This is just so much simpler and easier to grasp, in my opinion. And since we're in here, there's one more thing I'd like to call out. I mentioned previously that build times are getting longer. So how did we address that? So we chose TurboRepo for our official monorepo tooling. And we can see here that a build specifically for the web project, which is just typehero.dev, takes around 34 seconds. But if we use TurboRepo's remote cache, we see that a web build takes 170 milliseconds. And you can imagine in CI, building this over and over again, it's going to have compounding effects and you're going to save a ton of time. So definitely check out the docs. If you haven't heard of Turborepo, you won't regret it. So let's talk about how the Vercel platform itself enables the team to move faster. So if you recall previously, we were talking about how the platform allows us to make decisions faster around design, for example. I'm going to show you a concrete example of that. So we actually have an active PR that's doing some UI changes to the core experience in the editor. So I can actually go visit the actual environment here, and I'll go to exactly where the UI changes were. And they're just basically adding like some UI behavior here. So you can see how it just changes blue. However, we do have a test panel here and the behavior is missing here. So you can see I left a comment saying, this should have the same behavior. So meaning it should just highlight blue. And the absolute insane part here is I can make this shareable with anyone with the link. So I can copy this link, paste it in the PR or DM it to them directly, and then they can see my feedback. So, if everyone's familiar with GitHub, the PR process is really only good for reviewing code. It's not very good for actually reviewing like UI or design changes. The even crazier part here is that you can actually install this toolbar locally. So we have this as a local dependency. So you'll be able to see my comments as you're developing and, just addressing them as you're coding. And that's like an absolutely insane experience. I mean, that's hands down one of my favorite things currently. I'd love to dive into more features that we're leveraging, but unfortunately we are short on time. So I'd actually like to take the remainder of this talk to thank Vercel for having me speak yet again at NextConf. This is such a huge privilege and I don't take it lightly. But more importantly, I would love to thank Vercel for building tools so average engineers like myself can turn ideas into reality fairly easily. I'd also love to thank the contributors to typehero.dev. Without you, we would not be where we are today. I love you all to death, and I honestly can't thank you enough. But I'd also like to take this opportunity to announce that we're actually now in early access because of all of your hard work. So if you are interested, please go to typehero.dev, join the waitlist, and we will get you on the next cohort of early access users, and we hope to get your feedback. We hope you find bugs, more importantly, and we hope you just enjoyed the experience overall. Again, I don't take this opportunity lightly. I feel extremely thankful to be here, and I'll see you all around on the internet. All right, trash out.
Hi there. I'm going to be a little bit vulnerable right now and share something with you. Here's my GitHub contributions for 2021, which is not that much. Here's what it looked like in 2022. We got a little bit more contributions and more action towards the end of the year. And here's what I contributed this year, which is a lot more progress. Can you guess what happened? I'll give you a second to think. Okay, the second's over. I discovered Next.js the end of December 2022. Yes, I was late to the game, but hey, better late than never. Hi, my name is Hosna. I've been a software developer for a few years now, and in this video, I'm going to talk to you about how I've been able to build projects 10 times faster using Next.js. So let's get to it. When building projects before, I wasn't using a framework. I was doing everything manually. I was using Create React App. So I created my own client folder, and within there, I would set up everything such as the components, the assets, the actions, and the APIs that would be communicating with the server. And then I have to also go set up the server. And then within the server, I had my config files, I had my SQL tables, I had my handlers and whatnot. And this was just very time consuming to set everything up. I don't want to think about it. I just wanted to think about building the project. Now that you've seen a little bit of how I built projects before, here are 3 main areas that have saved me a lot of time when switching to the Next.js framework. They are file-based routing, route handlers, and data fetching. So let's start with file-based routing. It is where you define all your routes by adding, removing, renaming files within a directory. And here's an example of how to do that in Next.js. So here's one of my projects using Next.js. As you can see, I have one folder now. The structure is a lot more cleaner and easier to navigate. On my right, you can see I have my web app open. Now I'm using Next.js with the app directory. So in order to show you how file-based routing works, we have to go open up our app directory. And you can see we have a bunch of folders, and each one of these folders, except the API folder, which is for APIs, which we'll get to in a second, each one of these folders represents a route. For instance, if I want to see what is in the search route, I can go ahead and click the search button and it will redirect me to our search route. So this page right here is this section right here. Now, if I want to implement something like a nested route, then what I could go ahead and do is within our search folder, create another folder like other search or something like that. And then within that, I have to make sure I have a page. And then that'll be our nested routes. So now I just created a folder within the search folder, added our page. Then if I go inside a route and just add other search to the end of it, then we should be redirected to a page with other page inside of it because that's what we created right here. Now, the reason why it's showing a nav and a footer is because it's within our root layout. So within Next.js, you have pages, you have layouts, and you have other formats that you could add. We could also go ahead and take a look at dynamic routes. For instance, let's go to the search. I have a bunch of teams. I have a folder just for team, and within that folder I have a slug that I'm passing in, which is a team ID. I want to make sure that when I click on a specific team, I want it to route to that team page and pass in the ID so then it know it's a team. If I go ahead and click on this, now you can see our route has changed to our team and our team ID. So that's how that's being done. Show you how this works. I'm going to go inside our search, and then within here, let's look for the team. You can see we have teams here, and then within teams I have this link which represents this card right here that we were just showing previously, and you can see that we're passing in through our link our route that we wanted to go to. You can see we have the team, and then we have the team ID that's being passed in through here. So that's how that's being done for dynamic routing. So we could get this, and those are the main things that I've been using file-based routing for with Next.js. Now I'm going to talk about route handlers. So route handlers, you are able to create custom requests for a given route using the web request and response APIs. So I just opened another project that I've been working on, and I want to show you how I use the route handlers for this one. The web app is called SiteMuse. It's a place where you can input a URL link, and then it gives you a screenshot for both the desktop and the mobile version of that website. I'm using two APIs for that. It's one API to take the screenshot and another API to upload it to a storage base. And how I'm doing that is within our source folder, I have the app directory. Inside the app directory, I have the API folder, and then that's where I have my route. The route is inside the link and the create folder. So let's open that route up and let me show you what's happening. So as you can see, I have a post function and it's expecting a request as a parameter. I'm getting the information that was passed through the body and then checking if it meets certain conditions. If it does, I want it to perform a specific action. And then in the end, I'm getting the data that I received and then adding it into my database using Prisma. This specific link route is used inside the modal that's created here. So as you can see, I have this add link modal that pops up. If I go ahead and go to our create link modal, you can see that I am referencing that API right here. So I'm getting the values from above and then using my API route to then pass my values into it. So then let me show you how it works. If I get a URL, so here's roomgpt.io. If I paste in the URL link, so then we are going to get a screenshot of the desktop version of RoomGPT. So just give it a second. And then once it's done, you can see it shows up here. If I go inside, this is a screenshot of RoomGPT, what we just inputted in our URL. So that's how I'm using route handlers for this specific project. And then last but not least, data fetching. There are 4 ways that you can fetch data using Next.js. Number 1 is on the server with fetch. Number 2 is on the server with third-party libraries. Number 3 on the client via a route handler. And number 4 on the client with third-party libraries. The demo that I'm going to be giving right now is using the first method. So here's another project that I was working on. It was an X clone, and what I'm going to show you is how to fill this with dummy data. So as you can see, I don't have any posts right now. There's a great website called JSON Placeholder where you can get free fake API for testing and prototyping. So we are going to get one of the APIs, and there's one for posts and one for users. So we are going to fetch both of them, and then we're going to display whatever users have posted. So if we go back here, and if I go back inside our code, the first thing I'm going to add is our post component that I created, which we are going to pass our variables of the name, the username, and the post body. Next thing we're going to do is make sure that we have a dynamic. Since we are using multiple fetch requests, that's what we're going to have to include. The next thing we're going to do is create our function to get our users. And then inside that function, we are going to add this. We are going to fetch our data. Since we are in the server component, we are able to do that since it's an async function. And then our component is also async. So we are going to fetch our users and then we're going to return the response. And then after that, we also want to get our post. So let's create a function for that. And then within it, we are doing the same thing, but we're going to get it for post this time. And then the next thing we are going to need to do is call our function. So here's our function. We're going to use an await, wait until it's done finishing fetching. And then we are also going to get it for our posts as well. So we have our users and our posts. So we want to combine that data and then call it combine data. So we're going to map through the posts and the users, and for any user ID that is equal to the post of user ID, any post that is associated with a specific user, and we're going to return both the post and the user, and then we're going to use that data to then map through it and then input our data within our post function. So now you can see the data has shown up on the right side with the user and the specific data within it. You can see we have different users. So this is a great way for testing with dummy data, and that's how you get data on the server using Fetch. And those are a few reasons why I've been able to build 10 times faster using Next.js. Those were a little bit more technical, but I like to give a few honorable mentions that helped me along the way. And they are the Next.js documentation, stellar, beautiful, great, the increase of Next.js content on YouTube, and of course, how can I not forget ChatGPT, Stack Overflow, and GitHub issues. They helped me with so much. And yeah, that's it for me. I hope you got something out of it, and thanks for watching.
We built an AI-powered SQL playground using Next.js, OpenAI, Neon, and a bunch of cool libraries. Here's what it looks like. The first thing I'll need is a connection string for a Postgres database, and for that, I'll be using Neon. So I'll click connect, paste my connection string, it's connected, and I can view all the tables that are in my database, as well as the different columns, and for each column I can see its name, its type. We also have a SQL editor where we can write queries and run them, and the results will be displayed in this results panel here on the right. Now, we can click on Ask AI, and we have a dialog that pops up, and we can actually have like a conversation with an AI chatbot about just Postgres and the database schema itself. Now, there are a couple of examples here, but we can actually say something like, what are my tables? And it says your tables are episodes, podcasts, subscriptions, and users, which is correct. Now, we can also say something like, return 5 episodes. And it's giving me a query. Now I can either copy the query, append the result to the editor in case I want to modify it, or replace the code because I just want to run it right away. So I'll click on replace code and I'll run it. And we can see we get the results. And we can also see how long the query took to run. So let's actually see how this playground was built. To add the AI functionality to the playground, we're using OpenAI and the Vercel AI SDK. Now, OpenAI provides access to its AI models via an API, and that's what we're going to use. And we're going to use the same model that actually powers ChatGPT, which is super cool. And in case you haven't tried out ChatGPT, I don't know, like you're really missing out, so you should absolutely try it. But anyway, as for the Vercel AI SDK, well, it's an open source library that makes it easy to build AI-powered user interfaces and chat experiences. So let's actually see how we're using both of them in the project. So this is the UI code for the chatbot, and we first have a sheet component, and this is responsible for managing the state of the dialog, whether it's visible or not. And inside the sheet component, we have a sheet trigger. So this is the button that, when clicked, the dialog pops up. We have sheet content. So that's actually everything that's inside this dialog. And we have a header component. So this is the title and description of the dialog. We have messages, and this component is responsible for rendering the list of messages when we're chatting with the chatbot. And finally, we have a form that contains a prompt component. And this prompt component is actually just made up of the text input here, as well as the submit button. Now, you'll notice that we have a couple of values here. We have input, handle input change, is loading, handle submit, messages. All of these values are actually being pulled from the use chat hook. And this is a React hook that comes from the Vercel AI SDK. And it's super convenient. It gives us the list of messages. So this is just the current messages in the chat. We have the input. So here, this will be the prompt that the user provides. And we have a handler for updating this input value. We have a submit handler. So this submit handler, what it will do when the form is submitted, it will actually send a post request to an API endpoint with all of the messages that are provided, which is, again, super convenient. We also have is loading. This is a variable that, like it's a Boolean, that will let us know kind of like whether the kind of request is still processing or not. And we can use this value to display a loading indicator, which is, again, super useful. Now, we also have callbacks. So we have here an on-error callback function, and this will be called, well, whenever something goes wrong. And we can use it to display a toast, for example. And last but not least, we actually can include extra data whenever the form is submitted. So we actually include the database schema. So the schema variable here, we're actually pulling it from like state, and we're setting the state from another component, which will include the database schema. So this actually is Jotai, a very cool state management library for React, and it uses a useState-like API. So we're just pulling the schema here, and we're including it whenever we submit the form. And that's actually how the chatbot is able to answer questions about the schema. Now, let's actually see how the API endpoint is implemented. So this is the API endpoint for the chatbot. It is an edge function that accepts post requests, and we're first pulling the messages and the schema from the request body. We're then creating a system message, and this is a message that instructs the AI model on how it should answer questions. So for our case, we wanted to only answer questions about Postgres and the user schema, and for it to only return SQL without anything else. We are then creating a new message. So this is the user schema, and we're just passing in the database schema. And finally, we're pulling in the prompt from the messages array. So the prompt, the user prompt, will be the last messages in the array that is sent to the API endpoint. And then finally, we're just using the OpenAI SDK to make a request to the OpenAI API, and we are streaming the response. So that's actually how we get the typewriter effect. And we're passing in the system message, user schema, and prompt as messages to the messages array. And that's it. We then return a stream using the OpenAI stream function and the streaming text response, which are both from the Vercel AI SDK. And that's it. That's how you can build a chatbot using the Vercel AI SDK. And now it's actually time for us to explain how we're pulling the schema information and how we're actually running queries using the Neon Serverless driver. The Neon Serverless driver is a low latency Postgres driver for JavaScript and TypeScript. It allows you to query data from serverless and edge environments like Vercel Edge Functions and Cloudflare Workers, where you can't establish a direct TCP connection. And the way the driver overcomes this limitation is that it provides two options to establish a connection. The first one is querying over WebSockets. This option is designed to be a drop-in replacement for Node Postgres, the popular NPM PG package you might be already familiar with. And the second option is querying over HTTP. which offers faster response times for single, non-interactive transactions. Now let's actually see how we're using the serverless driver in the SQL Playground. The function used to run queries takes two parameters, a connection string and a query. We first establish a connection to the database, and then we send the query. And we get the result and format it in a way so that we can render it in the results panel. As for the function that pulls the latest schema information, it's a little bit more complicated than that because it does take a connection string and a schema name, the default one is public. We establish a connection to the database, but then we run multiple queries for getting all the tables, views, functions, triggers, indexes that are in the database. We then format it and return it. And since we now have the different tables, views, and functions, we now can generate a database schema. So this function will generate a single string containing a description of all of these objects. And that's what we pass to the AI chatbot. And because we're passing it, it's able to answer questions based on this new information, which is awesome. We had a lot of fun building this project, and it's actually live. You can try it out at neon.tech/demos/playground. And it's also open source, so you can check out the source code as well. Now, if you have any questions about using Neon with Next.js, about this demo, feel free to reach out. We'd love to hear from you. And with that, thank you so much for watching, and I hope you enjoy the rest of the conference.
Hello, everyone. My name is Silvia Vargas, and I will tell you how I added a real-time feature to my Next.js app. So here is my app for making and sharing polls. It has just 2 pages. The first page lets you create a poll, and the second one features the poll that you just created, and now you can share it with all your friends. Now, I want to see the votes as they come in real time. It's gonna look like this. The idea came from 3 places. First, a web component created by MattWeb that allows you to add a real-time poll to any page. Second, there was Daniel Rowe who used a live poll to gauge audience knowledge of Next during a conference. And then finally, Chris Early built an awesome app that lets you vote for cats. In fact, you can try my app right now and vote whether you think my demo will work. I think it will. It's a pre-recorded talk. But let's talk about why bother with real time. It is so important to build websites that are fast, and Next.js is perfect for that. Thanks to Next.js and React Server components, it has never been easier to build websites that are fast, especially paired with Vercel's Edge network. We can confidently guarantee that our users will have fast experiences because the rendering happens in an edge location near them. But we want more. We want the website to feel fast and be reactive throughout the user session. When a user does something on the website, we want these changes to be available to other users immediately without refreshing. There is this well-known technology that allows you to push data to your users while they are on the page. It's called WebSockets. However, Next.js is a serverless framework, and unfortunately, WebSockets require you to run a server. That's a lot of work to build, scale, and maintain. Enter PartyKit. PartyKit makes it very easy to push data to users through WebSockets without running your own servers. Think about it this way. Next.js simplifies rendering websites. PartyKit simplifies building with WebSockets. Both run on the same edge network, so they are fast together. Just like with Next.js, with PartyKit, you don't have to worry about hosting. You can just write code. Here's the code for a simple PartyKit room. This is all you need to make your app real time. When you're ready to go live, PartyKit will deploy it to hundreds of edge locations across the globe. Okay, let's build. This will be a technical talk where I will write quite a lot of code. So we will create a WebSocket server with custom logic that will run on PartyKit. Then we will connect it to our existing Next.js app using web standards protocols like HTTP and WebSockets. And then finally, we'll deploy the server. Are you ready? Let's go. First, let's add PartyKit. Run npm partykit init. And done. What this command did is added 3 things. First, PartyKit package, which enables building and deploying real-time servers. Second, PartySocket package, which provides a WebSocket client that will automatically reconnect if connection is lost. And third, a new directory where our server code will live. So now let's run the dev server on our local machine. And now the fun begins. We'll now set up the server for creating new polls. Let's open the server template that was created for us. And since each poll will have its own room, we can keep our poll data in memory. We can also use the TypeScript types from our Next.js app. We want to create the poll from a Next.js server component. Let's define a handler for receiving HTTP requests. When the app sends the poll information to the server, we can read from the request and store it in our class field. In real life, you'd want to validate it, but we'll skip that for now and just trust TypeScript. Also return the poll data that we already have so we can render it later. When the user submits the poll form, let's have the Next.js app send it to our PartyKit server. So let's find the file that generates the form. And we've already written the code to get the data from the form in our server action. Thanks, Next.js. So all we need to do right now is to send it to PartyKit. We can make your old HTTP request to the server. Please notice the ID. Every new ID gets you a new server. So every poll will have its own cozy PartyKit room. Oh my God, it works. But look, the data is static, so it's kind of faking. So let's change that. We'll now connect the poll page. So let's move to the Next.js server component that renders the poll. As you remember, our PartyKit server returns the poll data in the onRequest method. You can use it to render the poll on the server. You might have noticed the revalidate 0. Next.js will cache server fetches by default. We want to always have up-to-date votes, so we can disable caching. Because PartyKit runs on the same network as Vercel, this will be fast. And as I said, we started with static poll data. So let's read the response from the server and replace the mock data. And now our app is working. So far, we talked a lot about WebSockets, but we haven't actually used them yet. The PartyKit server is ready and waiting for WebSockets. So let's connect them. Let's go to the component that renders the poll. Please note that this is not a server component, so the connection will happen on the user's device. We could use the standard WebSocket constructor here, but PartyKit comes with a React hook, so we're going to use that. We provided the same poll ID, which we created a moment ago, so WebSocket will connect to the right poll. Now, we need to tell PartyKit what to do when we receive a message from the server. In this case, we want to update the votes. We can parse the message from the server and update the local component state. And the UI will update automatically. Thanks, React. Finally, let's make it possible to vote. All we need to do is send a vote message to the server when the user clicks the option. Our PartyKit server received the message, but doesn't know what to do with them. So let's fix that with a single method. Back to the server file. Our users vote by sending WebSocket messages, so let's add an onMessage handler. Then let's parse the incoming message and increment the vote for that option. And broadcast the updated poll to all clients so they see votes come in live. It's literally just one line of code. Now we can deploy. And look, this is our app. It's working. So in this QR code, you can see the demo. You can explore the code, but also as a bonus, there's a tutorial that includes production features like authentication, database, and so much more. So thank you for listening, and let's be friends, because everything is better with friends.
Next.js is core to everything we do here at Supabase. If we're building a new site, it's Next.js. If we're doing a tutorial showing some cool feature of Supabase, the example app is probably Next.js. It gets all the complicated stuff out of the way so we can focus on the bit that actually matters to us and our users. We recently rewrote our entire docs site to use Next.js, bringing it in line with supabase.com and the Supabase blog. This gave us massively reduced load times, but that was nothing compared to the efficiency of anyone on the Supabase team or even the community being able to jump into any codebase and know where to find the bit they're looking for. The combination of this and MDX meant we could share a huge amount of code across all of those codebases. Need a cool way to present some idea in a blog? Great! Now we can use that same MDX component to communicate that idea in the docs as well. Speaking of efficiency, we now use the next image component to load the most efficient version possible of each of your images in Supabase storage. We've even built a custom loader to make the integration between Supabase storage and the next image component almost as easy as loading a really inefficient version using the standard image tag. What? They can if they want to. When you head over to database.new and spin up a new Supabase project, you get your very own instance of the Supabase Studio. This is a dashboard for managing your hosted Supabase project, and guess what? It's also built with Next.js. Using a single stack across all of our apps allows us to move extremely quickly, and rather than wasting time re-implementing the same things over and over and over again, we can just let Next.js and Vercel take that while we build industry-standard tooling around emerging technologies like AI. Check out our new AI-powered SQL editor that helps you write complex queries without needing to be a DBA. This would not have been possible if we were spending all of our time implementing our own version of SSR, or maintaining build infrastructure, or practicing drawing the perfect triangle. This single stack mindset of having Next.js and Supabase across all of our apps means we can also share code across those different code bases, a concept made even simpler with Turbo Repo. This allows us to have a single entry point into all of our apps, making it a consistent experience for anyone new to the team or our amazing community of contributors. So we use Turbo Repo to make development across these three code bases feel like one, and then base paths and rewrites in Next.js to make them feel like a single cohesive experience for our users. We can even share the auth state of our user across all of these apps thanks to Next.js and a little package we created called SSR. We'll look at that shortly. The majority of users of Supabase are using it with Next.js. This informs the tools we build, the examples we put together, and the content we create. When the app router dropped, our YouTube channel basically became like a Next.js takeover. We became a great place to learn all about server components, client components, route handlers, server actions, and then if your new app router app needed a real-time hosted Postgres database, authentication, or file storage, you've already got Supabase right there, so just use the database, authentication, or file storage. And just like building apps with Next.js, a huge benefit of using it to create educational content is it gets all the complicated setup stuff out of the way, and we can just focus on teaching a single concept in isolation. This has never been more simple than putting together an example of fetching some data from Supabase using an async server component. Just run some stuff on the server, generate some HTML, it just works. And it's like 3 lines of code. This inspired us to build specific tooling to make working with Next.js and Supabase a seamless experience. This has been bundled up into an SSR package, which configures Supabase auth to use cookies so it works across all the Next.js server bits, like the get static props or get server-side props functions in the pages router, or server components, route handlers, and server actions in the app router. So let's check it out. Here I have a Next.js application that's fetching some data from Supabase. In this example, that's a list of reasons as to why Next.js is awesome. SSR, async server components, triangles, all the good stuff. But if we have a look at our RLS policies or our access rules for the reasons table, we can see that anyone can read these reasons. But our application already has Supabase Auth wired up, so let's modify this rule so that rather than anyone being able to read these reasons, we only want authenticated users to be able to read this data. So this policy now only applies to authenticated users, so only authenticated users can read reasons. We can leave this expression as true, as this is just enabling read access, and then we can click review to see the SQL that's been generated for us, and then save policy to run that SQL against our database. And now if we go back to our application and refresh, we can see we no longer have access to view those reasons. But that's expected. We're not authenticated yet. So let's log in our user, and we can see our list of reasons is back. But if we refresh, we can see we have this flash of a loading state before we get that data back from Supabase. And if we have a look at the code, we can see it's a little verbose for just fetching some data and then displaying it in a list. So let's try and simplify this a bit with those fancy new async server components. So let's remove use client from the top of our file. This makes it a server component, which means we can make it an async function, which means we can get rid of this use state and also this whole use effect block, because we can now just fetch this async synchronous data from Supabase directly in our async server component. We also don't need to handle that loading state because we can do that in a separate component, and then we can just alias this data that we get back from Supabase to be our reasons variable. And you can see TypeScript is not happy because we're not handling this null case, so we could just say if reasons equals null, or reasons.length is equal to 0, then we want to display that message. Otherwise, we want to map over each of the reasons and display them on the page. So we can get rid of our import for useEffect and useState, and we no longer need to import the reason type from Supabase because our async server component is now simple enough for TypeScript to be able to infer the shape of our data. Okay, cool. This is looking much simpler. And now if we go back to our application to make sure everything's still working and refresh, wait, what? We can't view the reasons anymore? So why isn't it working? We didn't change anything. Well, by default, Supabase Auth uses local storage to store our user's session, and this is automatically sent across with any requests to Supabase. In our access policies, we're checking, is this user authenticated? If they are, all good, we get our data. If not, we get nothing. So this works fine in a client component that has access to local storage, but in a server component, or any server context, there is no concept of local storage. If we want this to work in the same way, we need to configure Supabase to store that session in a cookie rather than local storage. And thankfully, we have this super helpful package called SSR, which does just that. So let's install that package using npm install or I at supabase/SSR. And then let's start from our login button, which is still a client component. So here where we're creating a new Supabase client, we instead want to use the create browser client function, which comes in from that new SSR package. And then we can move this one above our type import, and we can get rid of this import for Supabase.js. And that's it. Our login component is now configured to use cookies to interact with the user's session. Now we just need to refactor the data fetching side. So over in our to-dos component, again, rather than creating a client using Supabase.js, we want to create a server client, which is a function that comes in from that SSR package. And we can see this has lit up red because we need to give it a little bit more information about how to get and set cookies. So let's pass in some additional options. And in here we have a cookies object where we need to define how to get, set, and remove a cookie. So we can fix up our imports at the top again, move this up above our types, get rid of our import for Supabase.js, and then we can import the cookies function from next/headers. And then before we create a Supabase client, let's create a cookie store by calling that cookies function. And now to get a cookie by a particular name, we want to return cookie store.get and pass it that name. And then if we have a cookie, we want to return its value. Now server components only have read access to this cookie store, so we can't actually set or remove a cookie from a server component. We need to use middleware for that, but that's like a whole other topic. Don't worry, there's one command at the end of this talk, you run that, don't need to think about it. But for now, we could either leave these functions blank, we could just return, or if we want to be able to abstract this out into a helper function that can be used by those other server bits which can write cookies, like server actions or route handlers, we could say cookie store and then use optional chaining to say only if there is a set method do we want to set the name, the value, and spread in the options. And then a similar thing for remove, but we don't pass it a value, and it's called delete instead of set. And if we go back to our application, we'll see we're still not seeing that data from Supabase, but that's because we haven't authenticated with our new cookie-based auth. So let's click the login button, and now we can see those reasons that Next.js is so awesome are now coming back from Supabase, meaning it is correctly configured to use cookies across client, server, pages directory, app directory, anywhere in your Next.js application. It just works. So what's the fastest possible way to get started with Next.js and Supabase? Just run this one command, npx create next app, and specify the example with Supabase. My name's John Myers. You can find me on Twitter at johnmyers_io. Thanks so much for watching, and enjoy the rest of Next.js Conf.
I've been designing with 10 pot, open source, connecting every dot, server-side rendering next. You can call me Explorer Edge. Hello everyone. First of all, I want to say that it's really a pleasure to be here. And today I'm going to talk about Next.js is all you need for a fast-growing startup. And my name is Elizabeth Oliveira, and I'm Portuguese, and I'm a senior product designer at Zeta. Zeta is a serverless database powered by PostgreSQL, and the good news is you can use Zeta with Next.js. I'm the type of designer who likes to code, and I've been using Next.js for a few personal projects, also with Zeta. And for this reason, it's really a great pleasure to be part of this conference. And this is the agenda for today. I'm going to start by explaining what are the challenges of fast-growing startups, then what is the web app fragmentation, how to unify your tech stack with Next.js, what is a design system, how can you do SEO with Next.js, analytics and monitoring, the Next.js community and ecosystem for startups, and then I'm going to end up the talk with a few key takeaways. And these are the challenges of fast-growing startups. I'm just going to highlight a few of them. For example, rapid scaling, talent acquisition, market competition, the innovation pressure, customer acquisition, and brand consistency. And I hope you have seen Toy Story. This is Buzz saying to Woody, "To infinity and beyond, Woody. That's where I wanted our startup to go. But sometimes it feels like we've ended up in web app fragmentation instead." Startups have to focus on way too many challenges: market competition, talent acquisition, innovation pressure. So there are a lot of challenges that I previously highlighted. And sometimes they are way too focused on those challenges, and they end up with a new problem that I like to call the web app fragmentation. Most of the startups have this problem. They have different tech stacks. For example, to build a website, they use Webflow, and then for a documentation site, they use Docusaurus, and then for a blog, Webflow, and then for an authenticated dashboard, they use React. And this can lead to a disjointed user experience. But here's some good news. You can address this problem by unifying the tech stack with Next.js. And that's what we are doing at Zeta. We use Next.js for our website, for the documentation, and also for the web app. And there are some advantages with this approach: a more efficient development, a more efficient maintenance, improved SEO and accessibility, and a more consistent user experience. Unifying the tech stack can definitely lead to a more consistent user experience, but it doesn't address two of the fast-growing startup challenges: user acquisition and brand consistency. So if we want to achieve that, we need a seamless user experience. And to achieve a seamless user experience, we need a design system. And this is the definition of a design system: a collection of reusable components guided by clear standards that can be assembled together to build any number of applications. At Zeta, our design system uses Chakra UI, and we also have some custom tokens. Chakra UI gives us accessible components, and we customized the typography and the colors, and we also customized a few components. And on top of that, we have our own semantic tokens. So instead of using, for example, purple 200 or purple 500, we use primary color. This makes it easier to develop products by using these type of semantic tokens, because it's much easier to remember this type of names. And as you can see, these are our products, the web app and the documentation, and they are very similar because we're using the same components, the same color tokens, typography, and this leads to a positive user experience. SEO is one of the most important factors for gaining new users, and we can use Next.js for that. At Zeta, we use Next.js server-side rendering, and this enables the creation of social media-friendly content previews. As you can see here, when we share our blog posts on X or LinkedIn, we get these really nice content previews. And also Next.js provides a built-in support for dynamic meta tags and SEO attributes. So it's really easy to optimize the meta tags. And by doing this, we can ensure that search engines can easily categorize and rank our content. Analytics and monitoring can help startups to track user behaviors, troubleshoot issues, or make data-driven decisions. At Zeta, we are now conducting a few A/B tests. As you can see here, one of the tests is we are trying to find out which hero section works better to increase user signups. And we created this with Vercel and Next.js. And A/B tests are really a cool thing to do for your startup if you want to make data-driven decisions. With Next.js, you can also connect third-party analytics tools and use built-in performance monitoring. This way, you can find out things like how long it takes to your website to load, or how long it takes to show up on screen. Next.js has an amazing community and ecosystem for startups that can definitely help addressing the fast-growing startup challenges. And this is one plugin that I want to highlight because it made our life easier at Zeta. It is called Content Layer, and what Content Layer does is it grabs your MDX files and transforms into JSON data. And then you can import that data in your Next.js. And then you just need to worry about building the UI. So at Zeta, we use Content Layer in our documentation site, also in our blog. Combining Next.js and Vercel can improve a startup's performance and development speed. At Zeta, we use Vercel, and this is one feature that I want to highlight. It's part of the preview deployments. So at Zeta, we are only two designers, and most of the times we design with code. So we use a lot the commenting system from the preview deployments to gather feedbacks from our colleagues. Also, the Next.js community provides templates, starters, and themes, and you can find them on the Vercel's website. And if you are a startup and if you have a product that can work with Next.js, I would recommend you to share a template there. It is a great way for users to find your product, or also it's a great way to get started. As you can see here, let's say that we have this template. And we're reaching the end of the talk, and these are the final takeaways. So fast-growing startups often face challenges in web application development. Web app fragmentation can lead to disjointed user experiences. Next.js provides a comprehensive solution to unify technology stacks. Seamless user experiences are crucial for building trust and engagement. Optimizing SEO with Next.js enhances visibility and organic traffic. Analytics and monitoring tools can help data-driven decision-making. Also, by using the Next.js community and ecosystem, you can accelerate the development. And don't forget that the right technology choices can empower startups for success. And this is the end of the talk, and I hope you enjoyed it. And if your startup is not using Next.js, I hope you start using it, especially if you have different tech stacks. And that's it. Thank you.
Hi, I'm Dev, and I'm a dev. I'm also a DevRel. Let's talk about the iceberg of authentication. If you're building applications these days in a competitive market, there's some really high expectations from the part of your users, especially when it comes to auth. Most of it has to do with wrapping application security concerns around a delightful and intuitive user experience. And in case you didn't notice, there's a lot of stuff. There's passwords, there's OAuth, there's email verification, multi-factor, passkeys, bot detection, session management, and so on. A lot of stuff. And yes, the users are expecting it because everyone else is doing it. And you're not going to stand out in the market by offering less capabilities to your users. So let's go down this list for a bit. Passwords are the easy one, right? Well, unfortunately, there's a lot more to passwords than don't store them in plain text. Did you know that the US government has a department called the National Institute of Standards and Technology that very specifically outlines how to handle passwords, or as they call it, memorized secrets? Turns out having a combination of uppercase and lowercase characters and digits and symbols, also called the LUDS requirement, is a bad idea according to their research. Passwords end up being too predictable or too difficult to memorize, which means they end up on sticky notes. On top of that, we also need to make sure that the passwords haven't already been leaked before. And a majority of users out there don't use password managers that help them with these use cases. The Open Web Application Security Project, or OWASP, provides recommendations on how to handle passwords on top of the NIST guidelines. They recommend using the ZXCVBN library for password complexity testing and the Have I Been Pawned service to check for breached passwords. But this is not limited to new user creation. Every time a user signs in or changes their password, we should be checking if the password has leaked since the last time we checked. Speaking of, NIST also has a giant section on guidelines on how to handle forgot password cases that I don't think I have the time to get into here. NIST also has a section on how to store passwords securely. And as you would expect, it involves using a one-way hashing function, which is different from encryption, which is both ways. Hashing is really slow but necessary because we have to assume that these hashes will leak, and we have to make it very difficult for someone to break or brute force this hash. When a user signs in, you simply have to hash the attempted password again and check if the new hash and the stored hash are the same. The bcrypt library provides a great implementation of a hashing function that can be used for password hashing and comparison. But then these practices and guidelines and techniques tend to change over time as cybersecurity evolves, and you don't want to be left behind. You need to be on the lookout for when your implementation gets out of date and bring your apps and data along with you. Whew, we almost got through one of those points in there. I definitely don't have the time to get into others. Oh, looks like there's even more stuff in there that I didn't have there originally. But you probably have better things to do with your engineering time and effort. If you're using Next.js, you probably care more about building a great experience for your users rather than rolling your own infrastructure or Webpack configs. Speaking of Next.js, it has its own expectations from your auth. The programming model and the infrastructure setup that Next.js provides is very different from a lot of other web frameworks. And while it comes with a lot of new capabilities, it also comes with some extra considerations on how to set up things like auth in the most optimal manner. There's a lot of places where you can put sensitive compute that needs to be behind an auth layer. You need to make authentication functionality and state available at all of these places to serve their specific use cases. You want to conditionally render client components, fetch user-specific data in server components, protect sensitive actions and routes, and you can put a lot of auth rules right in your Edge middleware so that an unauthorized request can get rejected right away and doesn't even need to hit the rest of your application. Doing this requires understanding of a lot of the framework APIs available, how they work in different target environments, and how you can build your own APIs on top of the framework that are simple and solve the use case.
Many auth solutions that you might be using today heavily favor the traditional stateful model within a single origin database. So you would have a single server or a cluster of servers sitting in a data center along with a database. And every time there's a request, the server checks the database for an active session and responds accordingly. This is at a mismatch with how Next.js works, because Next.js wants us to push compute closer to the users at the edge. This traditional model doesn't quite work here and negates a lot of the benefits that edge compute provides. So we need to move away from this traditional model and push our auth to the edge as well. There's a couple ways to achieve that. JSON Web Tokens are a fantastic solution to achieve stateless auth, because once they are verified, we don't need to make a trip to the database to check for an active session. However, many JWT auth implementations swing too far the other way and completely lose the ability to keep track of sessions on the server. And we need those to be able to revoke an active session, or to grant elevated permissions, or simply to keep track of what devices are currently logged in. Short-lived tokens come in handy here, as they allow us to achieve stateless auth, while retaining the ability to manage active sessions. And of course, we need to ensure we polyfill some of the crypto APIs that are needed for the JWT signing and verification so that we can work with the various edge runtimes. The other solution is to bring the data to the edge with us. And there's some great solutions to do that today. But this is additional infrastructure that you would need to manage and pay for, and the edge data space is not yet fully mature. And we still have the cost of making a full round trip to the database for every request. Once again, you probably have better things to do with your time than to reinvent authentication to fit into the Next.js framework, its programming model, and its edge setup. Let's switch gears and talk about the developer experience for a bit. If you're using Next.js, you likely care a lot about the developer experience. One of the best things about React and Next.js is that they offer a way to build great user experiences with simple and powerful APIs that are a delight to use. This is what developers have come to expect from their dev tools. When it comes to what exactly we are doing with DX, there's nothing new here. It's actually all the stuff that I already mentioned, just from the perspective of the developer trying to build these features or integrate them into the rest of the application. Both these scenarios can end up being a constant back and forth between the front end and the back end. You can only work on the front end UI for so long before you have to go to your backend team and ask for APIs, which probably require integrating with other third-party providers for sending emails or SMS or authenticator apps or checking a breach database and so on. And then they also have their own database tables to talk to. And once that's done, you can continue working on your UI. And then you need a consistent way to represent the current authenticated state in your code and have all the relevant data there. Has the user verified their email? Do they have multi-factor set up? What's their role in the current organization? Are they allowed to perform a sensitive action, or do they need to enter their password again? All these attributes will be used to make decisions about what features to allow or where to redirect the user, and your auth APIs need to handle all of that. Not to sound like a broken record, but you probably have better things to do than to write the same auth APIs that have been written a million times for various different projects that all basically do the same thing. Building a great DX for the core of your application should be your much higher priority. This is why Clerk exists. The goal of Clerk is to provide you with authentication that meets the expectations of your users, your frameworks, and your developers. Protecting your Next.js application with Clerk is as simple as using the built-in middleware. You can specify which pages should be accessible to users who are not signed in. And in those pages, you can simply drop our pre-built components that handle really all the authentication capabilities that I've mentioned in the previous slides, and more. The user profile and the organization profile components offer a complete self-service portal for your users to manage their account and org data. And of course, you can customize the components as you wish, or build your own with our React hooks. You can get the current auth state on the client with the use auth or use user hook, and on the server with the auth and the current user functions. You can check out our Next.js quick start guide and authenticate your Next.js application in a matter of minutes.
Hello, Next.js Conf. Thank you for having me as one of your speakers. I'm so excited to be here virtually with you all. In the next 10 minutes, I'll take you on a journey of leveling up your Next.js developer experience using cloud development environments. Let's begin. So if you don't know me already, I'm Pauline Navas and I head up the community at Gitpod. I first found out about Vercel and Next.js at a hackathon actually, back when I was a student. Since my very first touchpoint with Next.js, it's been my go-to framework in every project I spin up. And I spin up quite a lot of projects. Outside of the tech world, I'm a digital nomad. In the past year, I've been to 11 countries, but I've been drawn to the beautiful country of Greece. Feel free to connect with me on Twitter or on LinkedIn. And as I'm going through my talk, share your learnings with me. I'd love to read them after. Let's kick this off. I'm going to go through a few slides and I would love to hear in the chat if these scenarios have ever happened to you. Have you ever been waiting for an npm install to complete and it just feels like it's taken forever? This one is a classic where your code works only on your machine and no one else's. I'm sure you've all felt this pain where it's been 2 weeks since you first joined and you still haven't committed a line of code because your dev environment setup is just not working. Or perhaps you've stumbled across a cool open source project that you would love to contribute to, but it has a long contributing process and a README that tells you to install X, Y, Z dependencies. But still, you want to power through. You may either be in an engineering team that is working with Next.js, or you're an individual developer looking to use Next.js as your next framework, or you're an open source contributor wanting to contribute to Vercel's open source projects. In every single scenario I've just talked about, you need to go through and select your project, check your dependencies, check out the branch, view a README, install tools, run your build, run your test, and finally, you can get started with coding. In other words, lots of friction. There are quite a few speed bumps before you can actually reach creative flow. This is where cloud development environments come in, or CDEs. They are on demand and pre-configured with all the tools, libraries, and dependencies required to be ready to code. So at Gitpod, we've coined 4 CDE principles. The first one is CDEs are on demand. They are instantly available and infinite. So you can just click a button to open your dev environment anywhere, anytime. You can also start multiple dev environments for multiple contexts. The second principle we're focusing on is equitable, which is all about making software development more accessible to everyone. Let me share a real-life example of this within our team. Axon landed his job here because of his active participation within our community. Before joining Gitpod, he was learning how to code, but faced several hurdles when his Chromebook broke down. But did that stop him? Absolutely not. He managed to set up a workstation with a keyboard and a mouse, all connected to a TV using his Android phone and using Gitpod as his compute power. Our third principle is consistency. Now, what do we mean by that? Well, in the world of Gitpod, every cloud development environment can be tailored to meet your specific needs. Think of this as infrastructure as code. It's the shift from treating infrastructure like pets, which are unique, to treating them like cattle, where each unit is identical. And the biggest win? No more configuration drift. Every setup is consistent. And last but not least, our final principle is extensibility. And this means that every CDE is not only modular, but also powerful enough to handle any use case that you throw at it. So let's go back to the scenarios I talked about earlier. So for all of them, they select a project. In this case, it's a Next.js project. And we remove all the friction. We can just start coding to get into that creative flow. Let's see this in action. All you need to do to start a cloud development environment is click this open in Gitpod button. You can also prefix your URL with gitpod.io/hash. But for now, since I've got the extension installed, I'll just click this button. I'm opening up a new workspace. A workspace is your development environment running in the cloud. If we head over to the Gitpod YAML file, this is the configuration file that keeps your environment consistent. You can open multiple workspaces and go through the same flow we just went through again and again for different tasks. And then once you're done making changes in that workspace, you can just get rid of it and forget about it once you've committed. Once this Gitpod workspace opens, what happens is we start your development environment by doing a npm install with all of your dependencies, and then a run dev, which starts up the dev environment, which you can see here. I've opened up an issue here to say hello to Next.js Conf, and you can just start a completely new workspace here. Again, you've got the Gitpod button, and what it does is it creates a branch based off this issue. We'll just start a new workspace. Let's just head over to pages and just make changes to the index. We'll say hello Next.js Conf, and we'll save. Now what we'll do is we'll commit these changes. And we'll just open up a new terminal. We can do a git push. And we can actually create a pull request directly from Gitpod. And we'll create that. And you can review that PR directly from Gitpod. Other cool things you could do is share your workspace. This could be helpful if you're collaborating with a colleague or a fellow open source contributor for your project. You could just share your workspace and debug on issues together. Gitpod is fully customizable. You can make changes to your themes, install any tool or dependency that you need for your specific project. You could also start your Gitpod workspaces directly from the dashboard. As you can see here, I've opened quite a few Next.js workspaces. You can also go to your user settings here and go to preferences. So I know as developers, we are very tied to our unique dev environment, but you can customize your Gitpod experience to suit your needs. What I showed you in the demo was using VS Code in the browser, which is the quickest way, but you can also use VS Code Desktop, and also we have integrations with IntelliJ and Terminal. You can also choose a theme and customize your workspaces even further using .files. You can really make your cloud development environment your own. Adopting cloud development environments can truly revolutionize the way you develop apps using Next.js. Imagine faster onboarding into your projects, opening up the doors for more contributions, and facilitating easier collaboration with your team. All of this can be achieved with just a click of a button or prefixing your Git URL. So you can develop, preview, and ship even faster. And from anywhere. Try it yourself. Simply prefix your Next.js project's URL on GitHub, GitLab, or Bitbucket with gitpod.io/hash. Once you've given it a shot, we'd love to hear more about your experiences. Share your stories, insights, and feedback with our community. Thank you once again for welcoming me here today. Enjoy the rest of Next.js Conf, and happy coding, everyone.
Hello, everyone. I'm really excited to talk about something that has been on my mind throughout this year. This year has been crazy, right? With generative AI and Next.js 13 app router, I think we've all had a lot of fun, right? And this entire talk is about the experiences I have had, which felt like, did I really just do what I really just did? Especially when it came to streaming, right? And that's what I'm going to talk about. How do you stream full stack UI and build a generative AI application on top of it? So streaming both AI and UI with Next.js and with something that I've been working on called langscript.dev. So who am I? I am Ahmed Awais. I love the web platform and the purple color. Maybe some of you are using my Shades of Purple Code theme. I thank you for that. I've written a lot of software on VP of Developer Relations, Google Developers, and Dev Network's AI ML advisory board member. And throughout all of this, things that I have done, I've written a lot of software, right? And I believe millions of developers are using my code globally, and also it has made it to Mars through NASA's Ingenuity, helicopter mission that I got to contribute to. But throughout all of this software, I think there's a generational shift happening nowadays. And that makes me super excited, especially for web developers. I believe the generative AI is single-handedly not only going to improve, but increase the amount of work, the amount of progress we are going to make on the web platform. And that makes me super, super happy. So without further ado, let's dive in. We only have 10 minutes here. So I'm going to be quick, and I'm going to be talking about some of the key concepts that I've faced, experienced, and built on top of when using the Next.js app router in generative AI applications in production, right? So blocking versus streaming. Time to choose streaming for both UI and AI, right? And definitely Next.js to the rescue. How streaming works is something you need to know before we begin, right? So on the left side here, you see this is a blocking UI. And on the right side here, you see that this is a streaming UI, right? A blocking UI is a UI which is blocked until we receive the full response. Imagine this is a text response, and when we fetch the entire thing, that is when we show it on the screen, right? But the streaming UI is different. Streaming UI is whenever we receive any small chunk of data, we start streaming it through HTTP streams back to whatever framework we are building on. We are building on Next.js, and with the capabilities we have in the Next.js app router version 13, it becomes super, super easy to use that streaming layer with React suspense and loading UI fallback, right? So what am I talking about? So before we go there, let's just quickly see what are the Streams API, right? So Stream API is not new. It has existed for quite some time. You fetch some data, and to oversimplify this concept, the chunks of data are sent to you, and you can process that data, and then these chunks of data are sent to your client, right? Which is our UI or UI framework like Next.js. And then you can use that to render that data. There's also an excellent article on web.dev by Thomas it's like a definitive guide on streams. I definitely recommend that you go through this. It has all the core concepts discussed, like what are the chunks, single pieces of data, right? Readable, writable streams, and how do you transform streams? All things about back pressure and stuff like this, which is probably a little bit outside this talk right now. But I definitely want you to go and read how streams work, so you can really enjoy and you can really use the powerful APIs that are now available to the web platform. And why are we actually talking about this? I think the biggest shift that has happened throughout this year is generative AI. I believe ChatGPT has been able to generate more than $1 billion in revenue. So, this generative AI is not a fad, in my opinion. It is generating actual revenue and actual value. Both Midjourney and GitHub Copilot have generated more than 100 million in revenue, if my recollection of loss isn't misleading me. So it's now more than ever a really good time to learn about how these things are working and use them to build awesome projects, right? And one thing you will learn in ChatGPT for, if you're using OpenAI's API in their API reference, is that they allow you to have stream data. GPT, generative AI, is a type of transformer. It is using multi-head, self-attention algorithm to generate each text. It works in cycles, right? It uses the prompt that you send it, the query, and it generates the next word. and then it uses your query, the next word, and generates another word. And then it uses that word and the word that it generated before, and it goes in again and again in this cycle of generating different words, right? And it's amazing how it is able to just generate most of the times something really good, right? But instead of when something like this AI inference is happening, something like a large language model is generating text for you, you can choose to wait while that generation completes, which could take, I don't know, anywhere from 10 to 40 seconds. Or since it is generating that text, you can start streaming that AI inference, that response, that text. You can start streaming that data through HTTP streams to your framework, which could be Next.js, and then render it using React Suspense on top of your client, and the user can start looking at that data right away instead of waiting 30-40 seconds for the entire generation to be completed. That is why I think streaming is so much more important. And how it works in Next.js is because of the app router. I know I just said that streams have always sort of existed, but I think the convenience and the developer and user experience of building loading UIs and streaming is mind-blowing when it comes to Next.js app router. And while building this, just a little bit of gotcha here, right? I can't believe I personally used to, build Next.js apps with the pages directory. So much more powerful and easier with loading UI and streaming and all of the things that app router enables us to do. So let's quickly see what we are talking about here. So imagine this is your blog, and here are your blog posts, and this is the content that is going to be loaded, right? So now with Next.js app router, what you can do is in a segment, let's say this dashboard segment, you can have a loading.js file or loading.ts file if you're a TypeScript fan like me. And in this file, you can create a loading skeleton, right? Something that shows some sort of fake UI that signifies that something is loading, right? What Next.js will do for you is on segment level, that it will use that loading.js file, wrap your page in a suspense wrapper. Suspense is coming from latest version of React, and add that as a component to the fallback of the suspense wrapper. Basically, your entire page will have this component loaded before you have the page's data actually rendered, right? And this will help users understand, even with SSR, there used to be, when the server was working, there used to be a delay when people used to hack around different UIs, a loading spinner or whatnot, to showcase, well, you are actually navigating from one page to another, but our server is kind of working and sending you data. Now with the app router and latest version of React, you can just use this loading.js file, and Suspense will take care of all of that for you. But things really, start to happen in a good way when you start working with streams, right? But before we go there, you need to understand how server-side rendering works. So first, all of the data is fetched on the server. Then the server renders an HTML page and finally sends it to the client. And client renders a non-interactive version of that page. And finally, React hydrates and the user can interact with that, right? And if we look at the timeline of all of this, you can see server is fetching data on the server side, and then it is being rendered. And then, it's taking a lot of time to load that content on the client. And finally, it's getting hydrated. With streams, what you can do is, instead of sending all of your data collectively, what you can do is you can start sending selective components. Let's say you have a user profile component, you have a weather update component, and you have a list of logs and a list of clients and a list of customers. You can have different components for each of those. Each React server component will be streamed in, right? Whenever, let's say your documents or your customers or your clients, each of these could be these, right? So your clients got rendered first because it was a short list, and then another component, and then another component. And while this is happening, you can use Suspense to show a loading UI. All of this sounds really, really easy, but man, it's so powerful, right? And ultimately, it will take shorter time. And the user who is using your website the web app that you're building will have a better experience, as all of these components will be streamed in parallel, as you can see here. I won't leave you here. I'll be actually showing you a small demo of what I'm working on. And for that, I'm using Lang UI. It's a beautiful components library for your AI projects. If you want to build a clone for ChatGPT, you can use it. It uses Tailwind behind the scene, and it's very similar to ShadCN UI, which we are all using nowadays, right? It's all copy-paste components. You don't install anything at all. For example, it has prompt containers. Everything is responsive and everything. It has history panels. It has your prompt input layouts and whatnot, and even complete sidebar layouts, which were really, really handy, right? With both the light and the dark modes, right? So using Lang UI, I've been building this thing called LangScript, right? In LangScript, while it's not out there, I've been working with a few of awesome folks on it. Feel free to go to langscript.dev and join the waitlist. But I'm really excited to demo it to you. It's built on top of modern full stack UI framework, the Next.js app router. It uses both streaming for everything, right? For both UI and AI. Right now, as you can see, there are lots of messages here in this message thread. But if I am going to write another one, for example, what's up? I know it's a silly message. You will see that AI will start streaming that response right here, right? As you can see, a bunch of things were streamed, all of this text chunks, and they were rendered in front of you right here. A couple of more things happened as well. The Next.js conf thread jumped from here to the top. For example, if I go to Next.js users guide, you can see it's here. And if I talk to it, tell me more, you will see it will jump to the top right there. How crazy is that? It's even more, visible when you're starting a new chat thread. For example, I'm going to ask it another silly question. Who is Ahmed West, right? So don't look on the right side. Look on the left side here. We are going to stream a response on the right side, and then we are going to add a title without refreshing the page and whatnot, right? So here it goes, right? Pressing enter. Look over here. Identifying Ahmed West, right? It happened right there and then, right? Without any data loading, without any refresh or whatnot. It's just so amazing. It's like, how Apple says, oh, so pro. That is how I feel about both UI and AI streaming cooked in and to build amazing, convenient user experience like this, right? Well, that's pretty much it, right? As you can see, I'm pretty excited about all of this. And I want you people to go ahead and start experimenting with both generative AI and streaming UIs. It's not complicated. I think we can all use better user experience when building new apps like these. And I'm always around. I'm gonna on Twitter. I'm gonna post a link of the slides and everything on Twitter. So feel free to ask any questions. With that, see ya. Thanks for listening. Bye.
Imagine you've been thrown into a new website project. And for this project, you're going to need to make a button. And for this button, you'll need 3 variations: primary, secondary, and tertiary. Now you'll need to multiply that by 11, because you've been tasked with building an entire suite of websites. And of course, in such a tight time frame, because that's how it goes, right? That single button, now copied and pasted to all 11 website repositories, has a new requirement of including an icon. So the development team splits up and adds the icon to each instance of this button. So far, so good. But then suddenly one of the team members is distracted by something. Could be the door, could be an emergency. Regardless, they miss a site. But imagine that this mistake was caught, and it's all taken care of. Your client's thrilled. So thrilled that they put out a PCR to include a 12th website. The copying and pasting will never end. Studies show that manual copying and pasting and fixing errors can lead to a 15% increase of project development time. For a small agency like ours, that's not just an abstract number. It translates to weeks worth of lost productivity and almost 60 cups of coffee per week. And trust me, we'd rather spend those weeks on more essential things than staring at our screens, fueled by a never-ending supply of caffeine, desperately trying to fix component inconsistencies across the websites. There must be a better solution than copying and pasting, leaving room for human error.
Thank you. Well, luckily, you have me. Hi, I'm Mel, and I'm the lead developer for Hide and Seek Digital. We're a small agency based in Australia and New Zealand, but our clients and even team spans globally. We're all about building simple solutions for complex problems that'll last through time. In my role at the company, I guide a dynamic team of talented individuals through the ever-evolving software development landscape. And this landscape is always developing and must be checked upon on the regular. By the time this talk concludes, 3 new JavaScript libraries will have likely emerged into the technical world. The situation I explained in dramatic detail was recently a complex problem that we'd faced. And personally, I'd aim to establish components correctly from the outset and iterate upon them, rather than repeatedly duplicating components while hoping to avoid the need for extensive and tedious adjustments each time that someone requested a new feature. This approach aimed to save both time and effort for our team.
Our journey began with Storybook, a versatile front-end tool that fosters design consistency across numerous components. It allowed our developers to work with each component in isolation, following the atomic design methodology as they built from atoms to molecules and beyond. Storybook also facilitated collaboration with designers by enabling us to send working components for review before integrating them into our sites. As our projects grew, we needed an efficient way to manage content across multiple websites. Enter Storybook, our chosen headless CMS. Its simple REST API allowed us to structure each site as a folder. By specifying the folder name, we effortlessly received the correct website data. This approach also enabled us to create a shared folder for common information, such as terms and conditions. This then eliminated the need for redundant data copying. But the real game changer was Next.js. With a full Storybook of components at our disposal, we sought a unified solution to manage all of our websites without the headaches of replicating code across 11 repositories. By harnessing the power of Next.js and using environmental variables, we could load only the necessary website data, ensuring that relevant styles, fonts, and assets were loaded instead of trying to hide 11 websites worth of data in a single instance. Integrating our Storybook components seamlessly into Next.js also provided us with TypeScript information, ensuring data consistency and adherence to our standards. Additionally, reusable functions from our Storybook found their place in Next.js, enhancing code consistency. Next.js's server-side rendering and static site generation capabilities allowed us to optimize performance. For instance, we could statically generate less frequently updated content, such as terms and conditions, granting them longer cache lives than dynamic elements such as products. We could do both at the same time. The versatility of Next.js extended to unique redirects for each site, managed through middleware. By utilizing environment variables, we could isolate redirects to specific websites, offering content authors the flexibility to create, modify, and remove redirects on the fly, while also enabling shared redirects. Next.js's proficient handling of URL rewrites ensured a clean user experience despite the complex routing structures. It became the powerhouse solution that brought everything together seamlessly. Our sites also require the ability for multilingual pages, a crucial feature in our global digital projects. With Next.js, we seamlessly integrated internationalization support, allowing us to serve content in multiple languages. This feature, combined with the power of Storyblock, made managing translations a breeze. We maintained a clear separation of concerns by handling the translations separately in Storyblock. This approach allowed content authors to manage translations without directly interacting with the code base. Through the use of Storyblock's internationalization features and Next.js's routing capabilities, we achieved a smooth user experience for visitors all across the globe. To top it off, we could now deploy new components and updates to all 11 websites with a simple click and a GitHub deployment action. This streamlined approach effectively consolidated our 11 websites into just 2 repositories. In summary, our journey led us from Storybook to Storyblock, and then finally, Next.js, a robust solution that transformed our web development arsenal. Each step addressed specific challenges, accumulating in a streamlined, efficient, and future-proof process for managing multiple websites. All maintained in 2 repositories, one for Next.js and one for Storybook. If we wanted to, we could have made this a single repository. But for the future of the project, we wanted to have the ability to share these components with other systems for the client. At the end of the day, 2 repositories is just easier than 11. With Next.js, we achieved the ultimate goal of being able to use only 2 instances to manage all 11 websites, eliminating the need for replicating code across numerous repositories. This in turn streamlined our development process and made it more manageable. If required, we could have each website on its own branch to lock down the component library versions per site. We've not yet had to do this because as part of our build process, we've included robust testing against all the websites using Cypress. In the grand tapestry of web development, our journey through these challenges and innovative solutions is nearing its conclusion. The combination of Storybook, Storyblock, and Next.js have been the driving force behind the success of our project. These tools have allowed us to build a robust and efficient system for managing multiple websites, and a few aspects deserve a little bit more highlighting. One of the remarkable advantages of our setup is the ease of which we can send updates to all 11 websites. With just a click of the button and a magic GitHub deployment action, we can propagate changes effortlessly. This means that our 11 websites are not isolated entities, but are a part of a digital ecosystem. This streamlined approach saves time and ensures consistency across all of the projects. While the possibility of consolidating everything into a single repository was considered, we deliberately chose to keep this only as 2. This decision was made with an eye towards the future, where we anticipate the need to share components with other systems of our client. This forward-thinking approach ensures that our system remains adaptable and responsive to evolving project requirements. Furthermore, if needed, the flexibility to maintain separate branches for each website ensures that we can lock down component library versions per site. This level of control enhances our ability to manage changes and updates, catering to the specific needs of each site. In closing, the marriage of Storybook, Storyblock, and Next.js have not only solved the challenges we face, but have also paved the way for scalable, efficient, and future-proof web development. The collaborative effort of our team and the power of these tools have transformed our project management and development approach. And as we reflect on this journey, it's clear that the icing on the cake has always been the integration of Next.js. It has empowered us to manage multiple websites effortlessly, ushering in an era of efficiency, consistency, and adaptability. With Next.js at the helm, our web development arsenal is stronger than ever, ready to tackle any challenges that the digital landscape may present. In the world of development, there are countless ways to approach a task, each with its level of complexity. It's a testament to the ever-evolving nature of our field. So thank you for joining me on this exploration of our complex project and the innovative solutions that we implemented. If you want to check out some more of the projects we've done at Hide and Seek Digital, we have a pretty rad website at www.hideandseek.digital, showcasing the unique humans and the work of the company. And bonus points if you can find all the Easter eggs. If you want to follow me, I'm on GitHub and LinkedIn, and I love to have a virtual coffee to chat all things tech.
Hello everyone at Next.js Conf. Welcome to my talk, Exploring the Power of React Server Components. I'm Aditi Ravichandran, founder and software consultant at Surya Consulting. I'm an independent consultant, author, and speaker based in Kansas City. And I primarily work with my clients on front-end technologies like React, Next.js, end-to-end testing, and so on. In this talk, we're going to explore React Server Components, which you've heard quite a lot about, and I'm here to give my perspective and an understanding of what React Server Components are. Before React 18, the primary way to render your application using React was entirely on your client. All of your code was client-side rendered, and there was no concept of server-side rendering at all. With React Server Components, what happens is it allows you to render your components on the server, thereby reducing the amount of JavaScript that is sent to your client. With Next.js 13, within the app folder, all components by default are server components. So let's go ahead and try to think about why the sudden change in paradigm and why server components. To understand this, we need to understand the timeline of events that have taken place. First, we had the client-side rendered applications with React. This was the go-to way, and there was no other way to render your React applications. In client-side rendering with React, the browser downloads a minimal HTML page and the JavaScript that's needed for the page. The JavaScript is then used to update the DOM and render the page. This is why when your application is loaded for the very first time, sometimes the user may see a blank white page. This is because the page isn't fully loaded until the JavaScript is downloaded and parsed. As your app grows, this JavaScript bundle grows, and it's going to put a lot of weight on the client side. To solve this problem, the concept of server-side rendering came into place. What happens with server-side rendering is that the HTML is generated on each request to a page. The server generates the initial HTML, and now the user doesn't have to stare at the blank white screen. Server-side rendering focuses specifically on the initial page load and sending the preloaded HTML to the client, and then that gets hydrated and downloaded before it behaves just like a typical React application. Remember that server-side rendering only occurs when you directly navigate to a page. Now, to take this to the next level, we have what's called the React Server Components. This is a complete change in the mindset of how we've been working with React applications all along all these years. You could use React Server Components in parallel to server-side rendering. They're not the same concepts, they're entirely different. React Server Components have components that run exclusively on the server. Here we're talking about component level. The code is not part of the JavaScript bundle at all, and it vastly improves the performance on each component level. You would have the choice to have each component be either a server component that lives on the server or a client component. With Next.js 13, we can now implement React Server Components within our production applications, and Next.js 13 does the heavy lifting of streaming and taking care of rendering these server components. What's cool with React Server Components is that you stay on the server and have access to the server infrastructure pretty much without any network round trips. So this is a big win in terms of performance. As we dig deep into the why server components, you will understand that now you're going to move your data fetching as well within your server component. What's cool about this is your server component lives in the server, which means you're moving your data fetching closer to your database. Your initial page load is faster, and the client-side JavaScript bundle is significantly reduced. This gives you improved performance by keeping large dependencies on the server. Now, how does a component tree look now with the introduction of server components? Take a look at a sample application for a conference page. You could have component level rendering with Next.js. You could choose each component on a page-by-page basis to be a server component or a client component. Here the pinks signify server components and the blues are the client components. On the root level, my application is going to be a server component followed by a conference page and a settings page. I'm going to have a speakers page within the conference page and the sessions page. You can see that we can mix up the server components as well as the client components, and React would be smart enough with its rendering of the components. When you have a typical web page, you would want to split the page into small components, which you always do with React, and all the non-interactive components can be rendered as server components on the server. The interactive UI like button clicks, scrolling, navigation bars, and so on can live as client components. Now let's take a look at the sample app that I have that is going to display a conference website, a hypothetical one, and display the speakers of the conference, the sessions that they're going to present, and so on. Now within this app, as you can see, we have a conference page and it has a speakers page as well as a sessions page. Now let's go ahead and check how the speakers page is set up. The speakers page here is essentially a server component. The speakers of this conference is pretty much static information. It's not going to change. And I'm going to fetch this data from an API call. Now this is a perfect candidate to be a server component. So by default, as we talked about, Next.js is going to have every single component be a server component unless specified otherwise. So I have a speakers component here, which is basically the speakers page. And as you notice here, it is going to be an async function because it's going to make asynchronous calls. And what's cool about a server component is you can make your fetch calls within the server component. You can see here that I'm fetching the speaker's information with an API call right within the component. And then we're going to get the data back and we're going to render our speaker's information as you see here on this page. It's going to render the speaker's name, their bio, and any other information that's important. Now, if you go into the fetch speakers method, I have it in a separate file here. All it does is call the Next.js 13's new fetch API, and it fetches the data for the speaker information and parses through it. So this brings us to the question of what is a client component now? When do you use a client component versus a server component? If you have hooks like useState, useReducer, and if you know that the component state would change at some point, then it's going to be a client component and it cannot be a server component. If you have interactivity within that component, things like a button click or a navigation bar and so on, that would be a client component as well. Any custom hooks, event listeners, they're all part of client components. And with server components, on the other hand, it would be something like we saw on the speakers page. If you're going to fetch data, that would be a perfect candidate for a server component. If you're going to store sensitive information such as tokens, API keys, it's probably better now to save them on the server rather than on the client. If you want to access backend resources directly, like make a database connection or even keep large dependencies on the server, all of that is now going to be translated into server components. To specify a component as a client component, you would have to use what's called the useClient directive. In here, you can see an example client component where I've added the useClient directive on the very top of the file. That would tell React and Next.js that it is a client component. You can see here that we have some useState hook being used. It is an interactive badge component, and it pretty much tells us whether a speaker is a featured speaker or not. You can see how this client component looks on our sessions page here, where we have some of the speakers, the special speakers, marked as the featured speakers. The server component calls this client component. If you go into our sessions page here, which is a server component as well, the badge client component is being called by this server component. Typically, you would have server components calling client components, and to improve your app's overall performance, you would have to move your client components to the leaves of your component tree. But that doesn't mean that you can never call server components within client components. There is a workaround to do that. You can pass server components to client components as basically props, something like this, where you would pass your server component as a child to your client components if you really have to. Typically, it's better to organize your code such that the client components are mostly at the leaf level and not at the parent level. What we're seeing now is pretty much a change in thinking how React works. What used to be client-side rendered code is now slowly moving towards server-side rendering and server components, where a huge chunk of our code can easily be ported over to the server. And that makes your app a lot more superior in terms of performance. This is a change in mindset, and it may take some time to wrap our brains around it. And the good news is that frameworks like Next.js are doing most of the heavy lifting for you. There is elaborate documentation on how to go about transitioning your application from Next.js 12 or 13 with the pages folder to the app folder, where you can tap into the features of React server components. Keep in mind that React server components and server-side rendering can happen in parallel. Your client components are still server-side rendered and not client-side rendered. You could still use server-side rendering for your client components, at the same time also tap into the concept of server components. If you would like to learn a little bit more about Next.js 13, I have a course on Pluralsight called Next.js 13 Fundamentals, and it covers how you can use the app router of Next.js 13. You can also reach out to me on Twitter at Aditi Ravi, or for my services, you can contact me at aditiravichandran.com and learn more about me. It was a pleasure talking to you all at Next.js Conf today. If you have any questions, I'll be hanging around here after the talk, and I look forward to the rest of the talks as well. And thank you, Vercel, for having me here today to present my talk on server components.
Hey there, my name's Alec, and by day, I'm an architect supporting the teams that build Disney Plus and Hulu. And by night, I build monorepo tools. Today, we're here to talk about scale. And when we think about scale, we often think about how many users or applications can serve at once. But there's another side to scale, and that's scaling your code base as your business and teams grow. Today, we're going to talk about how you can go from one application to an entire ecosystem of applications and packages using Next.js and TurboRepo. First, I want to cover two key concepts that we're going to be working with, and that's applications and packages. When we think about applications, we might think about the build artifact that we deploy. But in our case, I'm going to be using the word application to refer to the directory that our application lives in rather than what our users are going to see. When we think about packages, we might think, hey, that's how I share code. But our application directory has a package.json, and we're never going to publish it to a registry. So I want to challenge the common assumption that packages are just for sharing code and give you another way to think about them. The best packages are really narrow in scope. Maybe something like a resizable text area or a utility that does schema validation. The principle that packages should really only handle one or two things is what allows us to compose them together to build full, rich applications. And we already do this every day with React. We're going to apply the exact same composition principles that we use to build React components every day and apply them to packages. In our case, we're going to think of packages as a way to separate groups of logic within our application. Now, with that out of the way, let's walk through the scaling journey step by step. We're going to explore three phases of application scale, the challenges that you might encounter when you reach those points in scale, and some examples of how to address them. Let's get started. You may start with something like Create Next App or a Vercel demo application. You'll launch your MVP and start adding more and more features. Eventually, your codebase is going to grow, and you need some way of grouping your logic within your application. You might create folders called UI or components to hold shadcn components, or data to store server actions or fetching functions, or even utilities to just store general helper functions. These folders help group and categorize portions of logic within our application that can then be composed together to build pages and layouts. As our application grows, files within these folders can kind of become a grab bag. Eventually, it becomes difficult to know which files or functions should be used in what contexts and where the separation of concerns really is. The mental overhead for working with these files is going to increase with every new feature added and every new team member added to the project. So let's take our first step at modularizing our codebase to prevent some of this frustration. Let's reuse the exact same naming conventions that we used previously and break it down by the feature or context that the logic is written for. This is going to make it a lot easier to traverse your directory structure and find just the bit of logic that you need in order to compose your next feature. It's also going to add a little bit more separation of concerns to hopefully slow down spaghetti code and code bloat. This can and should be done incrementally, and you really should only do this when you start to feel that your original root level folders are getting a little bit messy. Now, your application is going to need to grow quite a bit more before you run into any additional friction, but at a certain point, you'll encounter really common growing pains. Your codebase might get so big that common tasks like build, test, and lint just take too long, and there might be so many files to navigate within your codebase that spaghetti code starts creeping up on you. Now, these problems are super common, and they're probably a sign that you're doing really well. But if you don't address them early, it'll cause frustration among your developers and slow down your iteration velocity. Let's solve this with packages. Because we have limited time today, I'm going to show you the finished product, but if you have any questions about how any of this works, please feel free to reach out to me on Twitter or X or whatever it's called at Alec Chernicki, and I'd be happy to answer any questions you might have. Let's get started. Here, I set up a really minimal monorepo using PNPM. In the packages directory, I have a feature checkout package whose source directory looks exactly like the structure that we set up previously in our application. And that's because it is. I just copy pasted the files from our application into this package. Here you can see 2 React components that are rendered on the right in our next application. But the crazy thing is that if I update one of these components, you'll see that I get the same exact hot reloading experience as if I built these React components directly into the application. This pattern is called the internal package pattern, and there's some great documentation for it on the Turbo Repo website. Internal packages gives us the ability to create stronger boundaries between bits of application logic while giving us the exact same developer experience of working on one application. This pattern gives us one huge advantage, especially when it comes to scale, and that's the ability to distribute your tasks across your dependency graph. Here's what I mean. When you're building one application, task time is going to grow linearly with the amount of code that you contribute to that application. But with Turbo Repo, we can parallelize the tasks across the dependency graph. This means that tasks are no longer limited by the size of your application, but by the size of your largest package. It's important to note that you're not getting all of this for free. You're effectively trading scalability for ongoing maintenance of dependencies and boilerplate configuration files for things like TypeScript and ESLint. It's also important to think of packages as an extension of your application. This means things like keeping versions of dependencies like React and TypeScript in sync with your feature packages and your application. Down the line, you might want to create a new marketing application. You might want to build a new feature that checks if that user's authenticated and redirects them to your product if they are. Using feature packages, you can reuse existing logic that you had already built, like authentication logic, in an entirely new application and business context. Feature packages not only allows you to create a separation of concerns within your code base, but also offers you a business agility that's impossible to achieve when you put all of your logic into a single application. There's one last point of scale that I want to cover, and that's when you have multiple teams working across many applications and packages in an entire ecosystem. If you try to put all of your developers into a single monorepo, you might start to run into some issues. Teams might want to start to use different versions of dependencies in their packages and applications, and there's totally valid reasons for doing so. Or you might start to encounter really long merge queue times just to merge a PR into main. Or you might start to see that there's completely different product life cycles for applications in the same monorepo. To combat this, you can become a multi-monorepo species, where every team works in a different monorepo designed around the business vertical that they work in. Teams can then build and publish the packages within their monorepos that they feel would be most valuable to teams in the ecosystem. You'll be able to get the same developer experience by adding a dev script for all of your packages. This will watch for file changes on disk, output the final build result, and your Next.js application will reload with the updated package. There are some common questions that may come up if you do choose to adopt the feature package pattern. One of them is, how big should my packages be? Your package can be 1 file or 100 files. Some packages just take more logic to work. As long as they stay narrow in scope and they only handle 1 or 2 things, you should be good to go. Folks also ask if they can move from an internal package to a built and published package earlier in their scaling journey. If teams look at your code base and see a little bit of it that they want to be able to reuse in their own applications, that means that the built and published package probably would have a narrow scope defined. In this case, it's totally okay to share it. The danger comes when you try to publish a package that's doing too much and you have to backtrack on the API and refactor it and communicate with external teams and manage dependency versions, and it can kind of become a nightmare. But if you feel like you have that narrow scope early on, go for it. The last question that I always get is, when is a monorepo too big? The mantra that's always helped me personally is, what changes together stays together. If you start to see that there's conflicting interests within the same monorepo, then it might be time to break it up. That's up for you and your team to decide based on the unique challenges that you're facing in that moment. Speaking of unique challenges, I just wanted to mention that the patterns that I presented today are just one way to break your codebase down. I've seen folks take the exact same feature package structure that we used earlier and break it down even further into separate packages for each of the features concerns. There are a million different permutations and ways to break your codebase down. What matters is the way that you organize your codebase works for you. Next.js and TurboRepo have added incredible monorepo support over the last couple years, and there's so much more opportunity ahead. I just wanted to thank Vercel for having me, and if you have any questions at all, you can reach out to me on Twitter/X at Alec Chernicki, and I'd be happy to compare notes. Thank you so much, and have a good one.
So, before introducing myself, I want to start with a quote of one of the smartest men to ever live that says that it is not the strongest of species that survive, and nor the most intelligent, but rather the one that is most responsive to change. And this is, of course, a quote of Dan Abramov. And this is going to be a technical talk, but it is going to be told as a story. And it is a story about myself and my team and our decision to, well, survive. So my name is Ariel. I'm a full stack engineer working for Ilmex. I'm based in Tel Aviv. I'm really obsessed with Next, React, TypeScript, and my dog. My dog is also really obsessed with clean code. And let's start telling our story. So around 5 months ago, Next released the app router going into stable mode. And around that time, I was getting really hyped. And I really thought that we needed to migrate. I went up to my boss and I told him that I think we need to migrate to Next. He looked at me pretty much like that and started mumbling stuff about front-end developers and trends. And understanding where he's coming from, I referenced him to check out the showcase of the companies that have already migrated to Next. Looking at the showcase, it's pretty obvious that we're not really hipsters here or something. And after looking at the showcase, he told me, okay, you know what? If you really believe in this, you have 2 days, put together a slideshow, and if you manage to convince the team, we'll migrate. So the following preview has been brought up to you by my boss that made me put this slideshow together. And this is about me trying to convince my teammates to take the next step. So when we're talking about migrations, we want to start by asking, why do we need to change anything? What's not working right now? And the problems that we had were not special for Ilmex. These are problems with the whole SPA approach. Any React client-side rendered application faces problems with performance. SEO is basically impossible. We have a lot of client code to maintain. The builds are pretty slow, and the client is doing some really heavy lifting. And if we try to group these into categories, this left-hand side would be user experience related problems, and the right-hand side would be developer experience related problems. And these two groups intersect on the client doing some really heavy lifting. The client is in charge of routing. It's in charge of bringing data from the server and storing it in the state, storing when it is waiting for the data, storing when the data is not wrong, is not right. We have to do so many optimizations, state management, memorizations, caching. And by this point, we have so much code that, of course, we can't avoid some Webpack dark magic, such as chunking, tree shaking, and whatnot. And at this point, the guy from my team had the most perfect comeback for this. And he said, but isn't it good that the client is doing all of these things? And I was like, oh, thanks, Tim, because that's exactly the perfect intro for the next bit that I prepared for you. So this is a short film about a guy named Tom that wanted a bicycle. So around 10 years ago, Tom wanted a bicycle, but the mechanic lived on the other part of the river. And when he asked for a bicycle, she told him there's no problem. She built him a bicycle and he was happy. But Tom is a human being. So within less than a year, he got bored of his bicycle and wanted a car. So we went back to the mechanic and asked for a car. And this time she was hesitant because this rope bridge can't really carry a car. Then she had an idea. What if instead of bringing him a car, she would bring him the parts of the car, and Tom can build the car himself? Tom thought about it, realized that it's better to build a car than to not have a car. He agreed, he got the parts. Tom became Tom the builder, built his own car, and he was happy. And then Tom realized, why should I stop with a car? I can build whatever I want. So Tom started building stuff that he was less and less and less capable of building. It wasn't really fun, not easy, but he still preferred having mediocre vehicles over none at all. And the years went by, the road bridge is gone. There is a real road now, but human habits don't change. And Tom is still getting his cars in parts. And Tom's story is basically our story, the SPA story. 10 years ago, network wasn't great. Inconsistency in JavaScript versions between the different browser, Node.js not being anywhere close to where it is today. And the only way for us to give our users a decent experience was to turn the browsers into builders. However, times changed, and we don't need to do this anymore. 5G era, all browsers in the green zone, Node.js even supporting native ES modules. And we don't need to be bringing cars in parts anymore. And that's where Meta frameworks step in and say, guys, we can just be getting cars now. And what we are doing when a client wants a car and we tell them, okay, take the parts and build your own car, what we are doing is actually far worse than that. And I want to explain. So when I'm talking about cars, I'm actually talking about pages. Each page uses different components. Some of them are shared. And maybe some of you are thinking to yourself, why is a car a page? Why isn't a car an application? And the reason for that is that your browser looks like this, not like this and not like this, and it does not have a time turner. Your browser only looks like this, which means that in any given point in time, your client only needs one part of the application, only one page. And what do? We couple it all up into one component. And when the client needs one car, we're not only telling him, go build your own car, we're telling him, go build all of the cars in the application. And we don't need to do this anymore because we could just be giving them cars and telling them to put petrol if they need. And let me explain, what do I mean by petrol? When we are working with client-side rendering application, the SPA approach, you would have a CDN that's serving an index HTML to the client. In this index HTML, we would have two things. One would be a very big bundle of JavaScript, and the second thing would be a very empty HTML. And these two together are the car parts for the browser to build the UI. With Next.js, things work a bit differently. We would have a server with a Node.js process running, and between this server and the client, we would have CDNs that are spread all over the world. And using React server components on the Node server, and that's why this is important to state that this is Node, because we are running JavaScript on the server here, and we would take the React components and already generate HTML out of them, which allows us to pre-build the DOM per each route. So each route can already get the HTML built for it. And the only thing that the client would have to do is to put some petrol, or in other words, rehydration. There are some elements in the DOM tree that require event listeners from the browser, and the client would re-render only those components. And by this point, of course, that the guy from my team intervened once again and said that, like, yeah, this is cool, but this is also a lot of effort. And he wasn't wrong, but I saved my strongest arguments to be last. And my strongest argument is this one. Looking at the React documentation, React officially recommend to build applications with a framework. React core team members tweet that if you're not working with a framework, you need to incrementally migrate to one. And this is not even about being cutting edge. This is not even about SSR. This is about understanding where is the industry heading. It's about us not wanting to be deprecated in a few years. There is a reason why this talk started with a slide about survival. And by this point, my team got convinced and they were like, okay, what's the plan? So the plan was to stop feature development and migrate our components into server components. I hope nobody believed that. I don't know how your paying customers get with infrastructure refactors, but the real plan was that we needed to continue delivering features. And the magic word here was incremental. So how do you refactor a tree that's constantly moving? Like, this is actually a really interesting problem. And the answer to how do you refactor a tree that is constantly moving, this movement is of course feature development. And the answer is that you don't. And the solution that we came up to this problem was as such. Right now, we are bringing them all the parts to all the cars at once. And then we thought, okay, maybe we can just make things slightly bit better at a time. So instead of bringing them the whole application to build, we would bring them smaller client-side rendered applications. So this whole thing would be split into a few smaller trees. And it's a lot easier to refactor something when you're talking about smaller parts. And in a long story short, what used to be our client application, if we look at the index, it went from something like this into something like this, basically from an application to a package. And from this point, we started breaking things down into server components. And thank you everybody for listening. If somebody wants to reach out to hear in more details in more than 10 minutes about how did we achieve what we achieved,
I'm Tejas Kumar, and I've been building on the web for over 20 years. Today, I run a small but effective developer relations agency where we work with developer-oriented companies to help them do great DevRel work, adding value to both sides. Today, we're here to talk about React Server Components, and we're going to talk about how React Server Components work, what they output, how they fit with React server-side rendering, and how they fit into the broader ecosystem. And the reason we're going to do that is because 1 year ago, Next.js 13, via the app router, pioneered first-class support for React Server Components inside Next.js applications. That brought with it a number of questions that ideally we answer together in our time together today. To do so, we're going to look at an application that we built with React Server Components, but without Next.js 13. And we did this in a top contour rough way to understand the underlying mechanism of how these things work, and then teach it to you so that you understand the mechanism, and that helps you do better work and make better decisions in your day-to-day work. To do that, let's start by exploring our application. So our application is this. This is the dog site. And what you see is a list of dog breeds. I absolutely love dogs. And if you click on Husky, you can see a photo of a Husky. If you go back and click on Bulldog, you see a photo of a Bulldog. And it's a different picture every time. It's really, really great. Okay, why are we looking at this website? Well, this website was built, as mentioned, with React Server Components. And to understand the complexity of it fully, we need to understand 3 concepts in particular. To start with, we need to understand React elements and how elements and components relate to one another. So let's do that. So this is ultimately a React element. A React element is just a JavaScript object. This little bracket here is a call to react.createElement. So this is kind of valid, right? And the output of react.createElement is a React element, which is this. It's an object with a schema type, props, and always one prop, children, but could be more. In fact, this is not fully accurate because there's also a type of, and this is usually a symbol for react.element. So this makes a React element. There are a number of other types of React elements, though. It's not just objects. For example, just the number 1 could be an element, false could be an element, null could be an element, or string. All of these are perfectly legal and valid React elements. Moreover, the type property of React elements could be a string for built-in elements like divs and spans and p tags, or could be a function to represent a function component. What is a function component? A function component is a function that closes over some state but ultimately returns JSX that becomes React elements, because JSX is calls to react.createElement. Okay, so a React element is a JavaScript object or a string, a number, or a Boolean, or even an array that represents fragments. So where the type property is either a function or a string. If the type property is async, then we start to encounter what are called server components. We'll get into those in more detail later, but fundamentally, it's really important for us to understand React elements in this way. Okay. And ideally we do. Now let's talk about server-side rendering. To do that, we look at a very bare bones, very hacky server-side renderer to understand a little bit of the mechanism that is important to then understand server components. So to do that, we look at the server that powers this application. So we have Express. This could be Koa, this could be Fastify, this could be whatever you want, and some utilities, particularly render to string from React DOM server. Render to string is synchronous and really not the best API for this. You should ideally use render to pipeable stream or something, but for the purposes of education, we're sticking with that. again, it's not something you probably want to use in production. So render to string we get from React DOM server, and we get some other functions. Okay, we instantiate our server. We listen to the dist or public directory for things like CSS and images and static assets. This is the meat of our server. We have a route parameter page, and this could be anything. This could be list, this could be detail, this could be literally, it's a variable, it's a parameter. We take the value of that parameter and use it in a dynamic import of a component in the pages or app directory. So rec.params.page represents the file name. We dynamically import that file from the file system's pages or app directory, and this becomes our component. The default export becomes our component. And this is why in Next.js, your pages or your functions, your components need to be the default export, because Next can then infer it from the default export. Whereas if you did something like a named export, this would be pretty hard for Next.js to guess. However, default is just standardized. Okay, that's why the default export is necessary. There's some mechanism for you. So we get the component, and then we pass it to render to string or render to stream, and we turn it into a string. So we turn this object into a string, and we send it over the network. And I need to be clear, every React application really is just a big nested object. So every React application that's composed of a number of elements is just this, right? Where children is further components. So this is representative of really most React applications. However, it's not P's, you have an HTML, you have a head, etc. Okay, so this is head. This is our server. So now that we understand server rendering, how does server components fit into this? To do that, let's look at a server component, and let's define a server component. A server component is a component that executes only on the server. A server component never makes it to a client environment, that is a browser. And because of that, you can trust them a little bit more. You can make server requests, database requests with authentication keys. It's totally fine because it's never going to make it to your client's untrusted browser. Moreover, since your server is asynchronous, server components can be asynchronous. Let's look at a server component. To do that, we're going to check out a different branch. So we'll go here and we'll git check out the second part called unwrap. And if we come here, this is a server component. So it's an async function that can just await a fetch of dog breeds and boom, render some UI. On the server side, everything's the same, except we have an unwrap function. And this unwrap function goes through this tree of elements, really, finds async stuff and awaits it. That's literally what we're doing. So we look at JSX. And as we mentioned, JSX can be a string or a number or a Boolean. And if it is, we just return it as is. If it's an array, like a fragment, we recursively find anything async, await it, but return the awaited values. If it's an object, if that object is a React element, then if it's a string, if its type is a string, that is, it's a built-in component, then if its props are async, we await the props by recursively calling unwrap on the props. This is because you can have props where children are an async function. So we want to make sure that we await those. If it's a function component, we call the component with its props and await it. Finally, if the props are async, we wait. So this function unwrap literally just like awaits everything on the server side. It makes sure all the data dependencies are handled and it's ready to go. Okay. Once that's done, we come here, and before we call render to string, we take this big tree and we pass it to unwrap JSX like this. And then this kind of waits for all the server components to finish. We get a big JavaScript object, and we render that to the string and send it over the network. This is the interplay between React server components and server-side rendering. You have one step that waits for everything on the server, and then you serialize that to a string or a stream and send it over the network. This should work. So let's build and run our server. Let's go back to port 3000 here. And it fails, and that it fails because we didn't await our unwrap JSX. So let's await it, try again. And there we go. So this page is fully React server components and server-side render. In fact, we're not using React at all on the client side. And that is the interplay between server components and server-side rendering. It's another misconception that server components output HTML strings. They don't. They output a big JavaScript object, that is React elements, that have been awaited. And because we get a big JavaScript object, we can then hand it off to the client side to do interesting things, like soft navigation in Next.js 13 with the app router. Let's look at how that works. So if we check out our, the fourth part of our repo, client-side navigation, we'll stash first. Stash. And then we'll check out part 4. Let's come back here. What we're doing is something interesting. On the client side, we're rendering our React app that we get from the server, but we're adding a click event listener to the window object, such that if we click on anything that's not an anchor link, we don't do anything, we return. But if we do click on an anchor link specifically, we prevent the default behavior, that is page navigation, and we do something else. What do? We call the function navigate. And what navigate does is it fetches our server and says, hey, give me a big JSX object. Give me a big React object that represents the next page. Then we take that output and we just like re-render our application with the next page's JSX. Okay, so it's not quite navigation. It's re-rendering the next page's JSX output on the client side, because we can server render now, and we can server render server-side components, server components. So we get the big JSX object and just re-render it. What does that look like? Let's take a look. So our application here, if we npm run build and so on, our application has soft navigation. So if we enter some state here in this field, and we navigate to Beagle, notice the state is persisted. This is soft navigation, because what's actually happening is we're not navigating, we're just re-rendering. Let's look at that through the network tab. So if we open the network inspector, we'll see what's happening. I'll click on blue tick. And we're saying, hey, React, give me the next page's JSX. And that's what we have. We have props, children. Notice HTML, children is head and body. So it's an entire page, right? And this page has children and children and children, but we're handing the next page over to React and saying, just re-render with this next page. That way we can persist state and do soft navigation, giving that fluid UX that you get from Next.js applications. The even better part of this is it's progressively enhanced. So yes, we do have soft navigation. State is persisted. That's really great. But suppose we don't have JavaScript. We still navigate, though state isn't persisted. So it's a progressive enhancement. Let's look at that. So if we come here and just disable JavaScript. So we'll still navigate because we're still fundamentally using anchor links, except the state is lost. And this is really great because JavaScript now enhances the page, but doesn't replace the page, the true intention of JavaScript. Hey, thanks for watching. I hope this has made it really clear what server components are, what they output, these big JSX objects instead of HTML, how soft navigation works, and how they fit into server-side rendering. If you're learning from and or enjoying this talk, I want to just plug, if I can, briefly, that I'm writing a book on React, on underlying mechanism that helps you understand these things and make better decisions in your work. The book is called Fluent React. It's on sale for pre-order, and I'd recommend buying that if you're interested in supporting me and really learning about these things, because this will help you in your job and also help you get the most out of Next.js in React. Thank you for watching.
Hi, my name is Corey Miller. I'm the senior front-end developer at ConvertKit. I'm responsible for all of our marketing sites. Today, I want to talk to you about a project I spearheaded last year where we converted our WordPress site into being a headless CMS website, where WordPress is kind of the database, the content management system on the back end, and Next.js handling all of our front end, all while being the sole developer on the project. Oftentimes, developers might be on a team of engineers. Maybe you have a team or a squad. You also might be watching this as the only developer in your company or on your team, and maybe you see an opportunity for your website. So today I want to talk about 3 things: getting your team on board, how to think through a rebuild architecture and process, and finally, how to get started on your own WordPress to Next.js rebuild. First thing I want to talk about is getting your team on board. No matter the size of the project, if you don't have buy-in from your team, it's going to be incredibly difficult to get anything off the ground, especially if you're going to be the only one who's working on the project. I had to communicate what we were lacking, I had to communicate what our options were, and I had to communicate what we would gain by completing this project and migrating from WordPress to this headless CMS using Next.js. We were lacking development speed and site performance, which was negatively impacting our projects and our SEO scores and overall conversion on the site, which is marketing site needs to have good conversion. Because of years of technical debt buildup, the builds for our site could take up to 35 minutes, which also meant that development time on projects was painfully slow. Dev tooling was poor, upkeep was painful, and trying to do anything without resorting to plugins like WordPress plugins, it was an absolute nightmare. It was terrible. Number 2, what were our options? 1, we could do nothing. We could just let it continue on. The second was we could fix what we currently had. We could rebuild how we used WordPress. We could continue to use that for generating our site. We could spend a pretty significant amount of time rebuilding how we use WordPress. And third, we could take that same amount of time and rebuild the site with a brand new architecture or framework. And then I had to communicate, well, what would we gain by pursuing this new project? Improved development time, which means we can move faster. We can get more projects and more updates out. It's going to give us improved SEO scores and performance, which means more traffic and decreased bounce rates, which ultimately means increased conversion, which is great for a marketing site. You need to bring facts to your team. You can't just say, hey, let's do this because it'll be better. Yeah, it'll be nice. It'll be fun. You have to make a case because there's a company and it's there to make a product. It's there to make a profit and be sustainable. And you have to help them understand why this is important. I had to get buy-in from most of the teams on the company since all of them interacted with the website in some way, shape, or form, whether that was content creation or using the site for migrations or sales. There was a lot of hands that kind of touched the website in different ways. If you could prove that the project will produce better results for your company, you'll be in a much better position to really make it happen. And these were the things I had to communicate to get buy-in from the team. Through several months of conversations and some testing, I started to get more and more people on board. And finally, we got approval to start what became known internally as Site 2.0. Once I had the support, I had to figure out kind of what was I going to do to make this site rebuild work. Now, don't skip this. A lot of developers often, I think they just want to jump into the code, yarn, install, I want to npx, create, I want to get everything down. Moving too fast without planning is the primary contributor to technical debt. Don't skip the planning. Start by researching the various technologies available. Then we also had to look at the site's requirements and document them. So document your site's requirements and various non-negotiables. In our case, I decided we wouldn't replace the CMS, but that the architecture of the new site should allow for moving away from WordPress in the future. You have to think about not just your current needs, but also your future needs. Will the new system support your growth in the next 2, 5, 10 years? Can you do it now so that you can grow as time goes on? The biggest piece of advice is don't reinvent the wheel. Stop. You don't have to reinvent the wheel. One of the best things that I did early on was to dive into a handful of open source repositories that were doing the same thing that I was doing. Namely, there was a great project by Colby Fayok from Space Jelly called Next WordPress Starter. It was a great open source little repository. It helped spark ideas, gave some great pointers on how to get started. The wheel already exists. There are a bunch of smart people on the internet who are doing the stuff you're doing. So once I had a rough idea, I prototyped a small section of our website using Next.js to see if it would actually work. This gave me an idea of performance and compatibility, brought up potential issues that we might run into. And doing this also gave me an idea of the timeline that we could expect that I could and you should bring back to your team. Now we can start writing some code. So finally, in this last section of today's talk, I want to talk about how we started the rebuild of our site in Next.js. For our site, we used a variety of great tools, obviously Next.js. Why else are we all here? We used a WordPress plugin called WP GraphQL, which uses the GraphQL querying language to retrieve data from WordPress. It's a fantastic way of getting only the data that you need. It's fantastic. We also use Apollo, which is a querying and state management library for fetching and handling data and state management for that particular data. There's a lot more that I can't get into today, but I started to kind of dial in what are the things that we're going to need that will help us scale and make this project happen. So the first phase was to break down the scope of work. Between WordPress pages and posts and a myriad of other content types, we had over 900 pieces of content that would need to be imported and handled by Next.js. The basic architecture I wanted to go for was to say, okay, we have Next.js, we've got pages, we've got posts, we've got everything in between, we've got guides, all these different content post types. What I need to do is we need to set up an architecture where I can create a page, I can request data, get data back somehow, and then create the page. We don't want to care about where the data is coming from. The page just needs to care about the data that it receives. It's a good idea to make sure that any changes that you need to make in the future require the least amount of edits in your code. So let's take a really quick example of one of the pages that may be the page that you make your posts with. In Next.js, we've got get static props. We're getting the params. We're taking the slug from the params that is created by the route. And we're saying, hey, I want you to use this resolved URL and get post by URI. What does get post by URI do? We have the Apollo client, which has a bunch of information stored in another folder. And we say, hey, use a query, get the post using this particular slug or this particular URI. This query is just simply a GraphQL query that says taking the URI as an ID, return back the post, content, and database ID. Again, this is a very, very simple example. This is not exactly what's written in our code anymore. All we're saying is give me the post. And then also here in get post by URI, we have this function here that says take that data and create a post object from this query, from this data. And then that returns the data into this post object, returns it back to the page at the very beginning, and then that data is used to send on through and create the structure of the page using that data. In no place did I mention which CMS I'm using. I didn't even say how I wanted to fetch the data. On this page, I could now leave this and say, I want to go update just get post by URI. I can just change where the Apollo client looks for data. As long as I'm returning that post object that's formatted correctly, the slug page, the post page, doesn't have to care about this. It just wants to know, did I get the data? Great. Is the data formatted correctly? Great. Now I can present it on the page. This sort of methodology changes it from being just like, just give me the data, to give me data in a way that's abstracted away from the data source. There's something in the middle so that I can have the least amount of edits to make any changes in the future. Do the work now so that you don't have to later. So how long did this take? Well, it took about a year. That's a long time. But as the only person on the project, we had other projects going on. We had other campaigns and features that needed to be shipped. But then it was done. It took about 14 months. What's the payoff? Well, mobile SEO scores on Lighthouse increased from an average of 20 to 30 on Lighthouse to about an average of 75 now. There's lots of work to do there still, but we're in a better place. Site build time decreased from that 30 to 40 minute build time that I mentioned earlier to 2 minutes. Page and feature development time, it's seen a massive decrease in time and mental overhead. We can get something in, I can get a design, and we can have something ready by the end of the day, which has also meant that my own personal happiness and enjoyment with coding has increased by quite a lot. So in conclusion, don't be intimidated by the scale of the task. Focus on the value and the long-term benefits that it brings to your team, your company, and to you as a developer. Planning is crucial. Always plan and consider the immediate and future needs of your site and for your company. You don't need to reinvent everything. There's a vast community out there ready to help, plenty of free resources and valuable experiences that you can glean from. Seek stakeholder buy-in early and often. Ensure that your team understands the benefits and keep communicating as you progress. Thanks for coming to my talk. Thanks for listening. Thanks for watching. If you'd like to get in touch, I'm not really on social media all that much, but you can send me an email at corey@convertkit.com. I'd love to hear from you. Thanks again for watching, and enjoy the rest of the conference.
Hi, my name is Edgar, and I'm a front-end engineer on the marketing team at Glide. Glide helps you build powerful software for your business. And today, I'm going to be sharing how we used the new features of the app router to build our blazing fast documentation. Enjoy. The first thing I want to talk about is the OG image by Next.js. And when you use the app router, it's native to you, and you can find it in Next server. Right, so the way we've used this is we've used it to create dynamic OG images for all of our pages. The way we did this before was with a tool that was sometimes down and not everyone had access, so you needed to know the right person to ping if an issue came up. These didn't happen frequently, but at least now we have everything in the same code base and it's much easier to make changes. Let's see how we use it here. So the first things that we do is we're using the new format for API routes. So the way that looks, that's different from the pages folder is you have an API folder, and then you have the name of the API route, and then you have a route file. And then for GET requests, the name of the function you're going to export is GET. For POST, delete, etc. as we go. So the first thing we're doing is we're pulling 3 search parameters for title, description, and section. So the title is the first part here, the description shows up here, and we're using section to create different backgrounds, as we can see here. So I'm just going to open another one, and we're going to see this is in a different section, so it has a different background. If you look at the URL, this is in the Essentials section, and if I just switch to this tab, this is in the Getting Started section. So I'll just talk about some of the other things we're doing here. We're pulling the enter font, which is the fonts that we're using here, which is really great. We're able to use custom fonts in this file. And then the way it's returned in the documentation is return new image response, which I mentioned. We pull directly from Next server instead of importing the whole package just in case you were using the pages folder. And then this is where we have background. And if I just open that quickly, these are the different sections that we have. And these are just SVG files that are rendering these pages. And then we have other colors that we use to color the text. I'll just head back here. And another thing that is great about this section is we have the TW prop, which lets us use Tailwind classes even in this file, which is also a benefit that helps us use the same CSS that we're using in the code base to render our OG images. And then the last thing that we have to do is set props for width, heights, any custom fonts that are being loaded, and the weight of the fonts, their style, and the name. Yeah, I'll move on to the next section. Thing is the new metadata type that's exported from Next. So previously, we did this ourselves. We passed in title, description, open graph, and all the other meta tags that we used. But now this is strongly typed, and Next just tells us which ones to use, and it generates for Open Graph, for example, it generates for Twitter, Facebook, and a couple of other platforms that we're going to need to check the documentation for. But this is for a basic page, and it's not what we want to show right now. So if we go to our dynamic pages, which powers up all the other kinds of pages in our documentation, we're going to see that we return this as a promise instead of just the way we use it here. And then we have a new function called generate metadata, which is native to Next.js app router. And then we pull in the fields that we need and their types. And then we can do things like title, description, open graph. And if you look at this section for 1 second, you'll notice what we spoke about in the previous section where we had dynamic OG images. So these are just passing the fields from the previous section. So the title, the description, and the section, and that gets rendered on the fly at build time. And we're also passing alternates for canonical tags. So this is one advantage of having this strongly typed, is that you just pull up the fields for meta tags and you type them in. And if for some reason you can't find one that you're looking for, you can head to the type and actually read it. So that was how we found the canonical tag, for example, just a quick search, and you will be able to find where this goes. Great, so let's hop on to the next section. All right, so our next favorite thing is how we fetch data into pages. And we're using a server component here, which is a new feature by the React team that Next.js has implemented in the app router, just in case you weren't aware of that. And in this top level page, we see that we're using a try catch, and then we fetch the data from an internal API page, which is this one. And then that data, we massage the data into what we want to have, and then we pass it back to the client. So these are the fields that we want that generate the page. and then we throw an error just in case one occurs. And then we come back to that page, and then we do another try catch. So if the request is successful, it's going to pass all the data to this page. And if it's not successful, it's going to throw a not found function. It's going to call a not found function, and this function renders a 404 page. Another great thing about this is how we have preview mode here, and it's easier to spin up preview mode for the content team because of the new features. And if it's in preview mode, the content team can see the latest changes that we have made in Contentful, which is our CMS of choice, and get internal feedback, implement the changes that were requested before we publish new pages. This has sped up our productivity tremendously. The content team loves it. I don't need to get pulled in anytime changes are made. Feedback is gotten the correct way, and then we publish. It's just helped us have a very solid ideation to publish workflow. And these are the API routes that handle this. So we have a GET request, and then we grab some parameters from the URL, which is our secret from Contentful, and the ID of the page that's being generated. If the secret is wrong or the page doesn't exist, we throw an error. And if it's correct, we grab the preview version of the page, and then we redirect back to the page and render the content. All right, so we've come to the end of the talk, and I hope you enjoyed it just as much as I enjoyed making it for you. I'm super excited for the rest of the announcements today and the rest of the talks. I hope you have a great day. I'm going to leave my Twitter on the screen just in case you want to connect. Feel free to reach out. Ciao.
Sup nerds, I'm Theo. Vercel invited me here to talk all about patterns that they probably don't recommend, and before they regret it, let's get started. So, made this quick repo. It's up online. You can see it at cursenextpatterns.t3.gg. Also have a GitHub link there if you want to play with it. These patterns go from kind of cursed but totally viable to extremely cursed. Be very careful from top to bottom. So let's start with the least cursed and most useful one, pagination via server actions. We've all had to paginate an endpoint before where we get some data and then we need to load more data and have a button or an infinite scroll or something. If you've used the new Next.js server component patterns, you probably know how painful this is to implement. You can fetch data on the server, but what do you do after that? Well, I have a fun little thing using new Next.js primitives that might surprise you. Here's the code for the pagination example. The important pieces here are the data view component that takes in initial data with get server data. Get server data is a pretty basic thing. I just have server data, which is an array with a bunch of values. Could I have generated these? Sure. Who cares? It's a demo. Then we have the get server data function. Notably, at the top of this file, we have the use server call. This could also have been placed inside of the function as so, but it doesn't really matter too much. As long as you're exporting an async function that has the use server assigned to it, either through the file or through the function, this will work. So here I take an optional current. So this is where we're starting from. And then end is that number plus 5. So we get a really quick starting point and a slice to the endpoint. So what am I using this for? Well, if we hop over to the actual data view component itself, you'll see we have an initial state that comes in through this initial data prop for the state, and then a basic load more function that uses this get server data call. But wait, isn't this a server function? Well, the fun thing with server actions is they're not just good for forms. You can call them as async functions anywhere in the client, and this is effectively compiled into an RPC call that returns the data. It's even type safe, so it knows that the return result here is a string array. So I do this call with the data.length, which will index from the right point forward, and then I set data to this value here, which is the old state plus this new state. And it really is that simple to use server actions to fetch and paginate data. Obviously, your pagination logic is going to be more complex in production. This is meant to be a simple example of how to use this pattern effectively. But as I said, this is just us getting started. Things get way more cursed from here. So let's take a look at the first particularly cursed pattern here. Global this as an SSR helper. Have you ever had a problem with hydration where you had context on the server that you needed on the client and not necessarily a direct relationship between them? Like, let's say you have a client component that's being mounted arbitrary places in your app and you don't actually know if you can pass the server context to it via a prop. Boy, do I have the pattern for you. The content below is client rendered with server rendered content without props being passed. So what do I mean about this? Well, you'll see here I have a server content.txt file. This is where that content is coming from. You could imagine this is like a database call, some server-side only stuff of some form. I'm just using a text file because it's easy. But how are we actually using this? If we hop into my global this page, you'll see some interesting stuff going on here. First thing is server content is await fs.read file to string. So this is just the string coming from the server. This is not a use client and it's a page, so we can fairly assume that this is a server component. So what do I do with this content? Well, I throw it in this global this embedder. This is the hacky part. And then I mount some client component. And if I go to some client component, you'll see I have global this server content.content or content was not loaded. Ignore these type defs, they're a mess, but ideally you put this in a global somewhere. The interesting piece here is the global this embedder. And again, this is where things start to get a little bit cursed. If we hop over here, you'll quickly see some weird stuff going on. The two key pieces here are the use of global this, which is a global that exists both on client side within the browser as well as on the server side. However, when you put something in global this on the server, there is no guarantee it's going to be there on the client. In fact, it probably isn't. So what I've done here is a bit of a hack in order to create this global this context on the server and on the client such that you have access to it in both places consistently. So the first thing I do is I take whatever props you've passed here and I set them to this server content value. Make sure this is unique because if you use this more than once, they're going to clobber each other pretty quickly. And I'm using the or equals here. So if this already exists, we don't set it. But if it doesn't exist, we do set it. Very useful on the client side because immediately afterwards, I write this hacky script, HTML, global this server content set to json.stringify props.embed on server. So what we're doing here is we're stringifying the server content value that we passed as an actual JavaScript string. And then we embed this as a script where we dangerously set inner HTML to this HTML content. This is terrifying, and I absolutely love it. Most of the time, you'll never need something like this, but if you do, it's incredibly helpful. And since we're doing the use server inserted HTML hook, we know that this code isn't going to run on the client, even though this is a use client component. This might seem terrible and hacky and like you would never, ever, ever need to do that. But boy, do I have some good news for you, because I actually ripped this code directly from Upload Thing. This code is nearly identical because I ripped this straight from Julius's contribution to Upload Thing. What are we using this for, though? Well, with Upload Thing, you have to define what uploads are valid and allowed for a given user. And we want to make sure that that context is accessible to both the server and the client. So we created this optional helper so that when the page loads, let's refresh this to see, without the SSR helper, you'll see a loading state before the context of which content's allowed appears. This would normally say something like images up to 4 megabytes. But if we don't have that context coming from your file definitions on the server, we can't render that on the client without doing a data fetch. Before we had this helper, we were actually fetching from an endpoint on your server in order to get the permissions that this component has. And that was not great, specifically for the SSR experience. And by introducing this next SSR plugin helper that we created, we have made it so that the client will always have the correct state, and you'll be able to avoid all the weird hydration errors that you would normally expect doing some crazy stuff like this. Okay, so how does it get more cursed than this? Boy, do I have some fun to show off next. So this next pattern originally comes from Galstar, Schniz, Schlez, whatever you want to call him, a phenomenal employee at Vercel that likes to push the limits of the technology. And when he showed this to Tim, the immediate reaction was, I'll get the exact quote, "Shocking that this works, I wouldn't recommend." So yeah, this is, although created by Vercel, explicitly not blessed by Vercel, and also explicitly very cursed. So you'll notice when I go to this page that this number goes up. So what's interesting here is not that this component updates, because obviously I could do that on the client side. What's interesting is when we look at the network tab, all of this content is being streamed in on the generator's route, which is the URL that we're on right now, localhost 3000/generators. All of this new content is being streamed in. So how are we streaming updates that will allow for one component to be updated to different states? Well, we're using something I don't normally recommend, generator functions. Yes, we're actually using function star for this amazing cursed pattern. Here we have steps where I starts as 0. We yield step I plus I. We await sleep, which is your basic sleep promise. We yield again, await, yield again, await, and then return the final result. Yes, you can actually do this in Next using server components right now, which is utter chaos, and it's so cool. How does this actually work though? Well, if we go to the result for generator component, it actually takes the previous results and uses that as the fallback, and then calls itself recursively with this generator using the values that are being yielded as it goes. And it doesn't resolve the suspense until it's actually done here, where we do the result.value for the final value. So as long as you're still generating more results, we will be able to keep generating more components and streaming down the updated results. I did not believe this worked when I first saw it, and I had to play with it a lot to confirm. But this is, if you need a component to get multiple different states from the server during one fetch, I can't imagine a better way to do it than this, even though I don't know I can recommend it wholeheartedly. Yeah, this is a really crazy, really cool pattern. Do you see any cool ways to use this pattern though? If so, I'd love to hear about them in the comments. Please let me know what type of curse stuff you're going to do with this going forward. Wow, we're already at time. Thank you again so much for inviting me, Vercel. It's really awesome getting to share these maybe not recommended patterns with your audience and pushing the limits of what Next.js can be used for. If you haven't already checked out Upload Thing, give it a shot. It's the easiest way to upload files in your Next app. And check out my YouTube channel too if you want to see more cursed stuff like this. Thank you guys as always. Really appreciate y'all. Peace, nerds.
Hey there. I'm Ronak, CEO at Reducto AI and a graduating senior in AI and decision making at MIT. A few weeks ago, I built a viral developer tool that gives large language models long-term memory. And I did it in 8 hours. Never before have developers had the tooling to move this quickly in building powerful applications. Today, I'm going to talk about rapid prototyping in Next.js and share the story of how I built Rememberall, a long-term memory system for language models that integrates in a single line of code. Let's back up though. Why did I decide to build this? Well, it started when I was coding an AI-powered journal app for myself to help me introspect a little bit better. But I was really frustrated when the AI features that I was building wouldn't remember important details from my past journal entries and conversations that I was working with. Off-the-shelf solutions like LangChain and LlamaIndex just wouldn't cut it. They were hard to integrate with my existing LLM calls and required really inflexible prompting constructions that were hard to hack on and build on top of. I knew what it would take to build a solution, but it was a lot of work to build just for myself. For one, anytime the user would send a message or engage with a language model, I'd have to set up an extraction process to take out the pieces of information that were relevant that I should remember for the future. Then I'd probably have to set up a vector database to store all of that information and retrieve it dynamically as necessary. And then I'd have to manage inserting the relevant context back into the calls to the language model and handle all sorts of different cases like too much context for a limited context window of a language model. If I was going to solve all of these challenges, I decided that I wanted to build a scalable system that would be useful not just for myself, but also for other developers. So with that, let's take a quick look at a demo of Rememberall. I might type in as a user, I love red wine. It's my absolute favorite. Rememberall will automatically grab this information behind the scenes and save it. Every request and all saved context is immediately available in the dashboard. When I query again for what is my favorite type of wine, it'll automatically pull out the relevant context. Now, developers can add documents for the system to reference as well. Let's say I want my system to recommend a set of wines from a restaurant menu. I'll upload it as a PDF and add it as a document context. Now, when users ask for a wine recommendation, it will pull from this list and remember the user's favorite types to recommend. This means that the language model's responses are customized not just to your internal company's data, but also to the past conversation history with users. And of course, you can see the injected context and logs for every single request made through the Rememberall system, whether that's something that's logging new memories or pulling in existing context. And the best part is that developers can integrate this into their code with a one-line change to their existing OpenAI call. Using Rememberall can transform all sorts of AI agent applications, From my original challenge of building a smarter journal to smarter NPCs, customized advertisements, or even personalized tutors improving online education resources. So how exactly did I build this? Rememberall is built primarily on top of Vercel's Edge network. By using an Edge function, we can allow developers to add a super fast proxy on top of their OpenAI calls that records relevant information for future memory and automatically manages the limited context of the language model. This allows for the one-line integration on the end of the developer, but it also restricts some things that we can do because we can't do all sorts of different types of computation on the edge. It also brought up some other problems. I knew users wouldn't be able to stack multiple proxies, so I had to provide a lot of the value that Helicon and some of the other observability platforms that there are for OpenAI and these other LLM APIs were building. I dug into the code of some of these other open source tools that use Next.js, like LLM Report and DubSH, to learn a little bit more about how these analytics platforms work. And I learned to use platforms and tools like Tremor, Tinybird, and other really powerful open source technologies to make this work a lot better. So this is the highest level overview of what's going on behind Rememberall's proxy. So a user on an LLM powered application will make a request, and instead of going straight to OpenAI or Anthropic or any other LLM provider, it'll instead be routed through Rememberall's Edge function. And this Edge function will basically insert some extra special context. It'll go back to the LLM provider, and then the returning request is going to be going again through the Edge function and passed back to the user. And the advantage of doing this on the edge is that we can kind of make this code, this edge code, run really, really close to wherever the user is and reduce a lot of the latency that comes from these messages traveling long distances. Let's actually break down what's going on inside of this edge function and how and why we're doing this. So you can see I've kind of drawn an expanded view of this edge function right here. And you can see the incoming message comes in, and the first thing we do is calculate a text embedding for that incoming message. And so the text embedding basically extracts, you can think of as a vector representing the approximate meaning of the text that the user entered. Then we go ahead and make a lookup in a vector database. I'm using Postgres, and pull all of the most relevant memories associated with that user, things that I should remember, and I pull those out from the database. And then I add that to the prompt that is sent to the LLM provider. So that's kind of these three pieces right here. Then once the LLM provider responds very quickly with a stream of a response, I do something kind of interesting, where instead of returning the stream directly to the user or waiting for the stream to finish and then returning to the user, I duplicate the stream. I split the returning stream of text into two different pipes. One pipe goes straight back to the user. The other pipe is listened to. And while this pipe is waiting for the response from the LLM to finish, I don't do anything. I just wait. And the beauty of running on Vercel's Edge network and using these Edge functions in Next.js is that while I'm waiting, I'm actually not paying anything for the Edge function execution. So I just wait until the LLM call is finished. And as soon as it's finished, I do a couple of different operations. I log this query to Tinybird, which is a real-time database that I learned about from some of the example apps that I've seen open sourced on Next.js, like Dub.sh, I believe uses it. And so I log these queries to Tinybird, which I can then pull from in my dynamic dashboard. I also save the queries into my Postgres database, and that's what allows me to open up queries in my dashboard later on and kind of see what's going on. And finally, this is the most crucial piece, I query the language model. I make a secondary request to OpenAI using a much lighter weight model. And this request is basically structured such that I'm pulling out a specific JSON format of output from the model. And that output I can then use to update my vector database and basically make changes to it. You can see the prompt that I'm using here on the screen. And the basic idea behind it is to pull information out of the user dialog and then to dump that and update the vector database of memories that I'm serving to the user. So on the front-end side, when making architectural decisions, I prioritized two things. One was the speed of iteration, and the second was end-to-end type safety, which helped me make fewer mistakes and just move quickly during the hackathon. So the first thing is I built everything on Next.js App Router, which was like a really stable bedrock to kind of build the rest of the application on. And then in terms of the front-end, back-end interactions and stack, I leaned on Theo's T3 stack. So that was using Tailwind for the co-location of my styles and my markup, TRPC for making type-safe calls to the Next.js backend, and Prisma for working with my Postgres database in a type-safe way as well. And then for all of the front end, I used Vercel's own ShadCN's UI library, ShadCN UI, which is kind of best in class in the sense that it allows you to bring in your UI components and co-locate them in your own project and be able to edit them and modify them over time, which allows for really quick iteration and flexibility. So what are the key takeaways here? First, the developer experience is crucial to prioritize. This means choosing the right tools, even tools that might cost a little bit more at the beginning, like using serverless technologies, Vercel, Next.js. to maximize developer productivity, as well as designing tools that are easy for devs to integrate and build upon. Second, don't reinvent the wheel. I was inspired by so many devs and their open source projects that I looked through, whether that be for observability and analytics to just how to build with Next.js, building like type-safe applications from end to end. I was especially really inspired in this project by the work of Stephen Tay, Hassan El-Magri, Billion Verma, and many other developers who have really built impressive open source applications. I was able to iterate much, much more quickly by combining insights across these open source projects and learning about how these systems work together. Finally, and this is something I learned especially after releasing this project and getting a lot of feedback from users, obscure nothing. When you're building, especially at the cutting edge, like with all of these LLM applications, if you're building a developer tool, expose all of the bells and whistles for devs to play with as much as possible. And if you can, open source your project so people can actually dig into the guts, clone and fork and make changes as is necessary to kind of improve the system and make things better. So what's next? Well, I'll be graduating from MIT in a few months and moving to San Francisco to keep building. I'll be working with an amazing team at Reducto AI, creating magical tools to help developers build faster and smarter. If you want to follow along on my journey, check out my Twitter, Ronak Does Dev, where I'll continue to share both the challenges and insights I gain from building in public. And one last thing, I'm happy to share that today we are open sourcing Rememberall. I've gained so much from the open source community, and I'm so excited to be able to give back with this project. If you can, please give our repo a star, and feel free to contact us and leave an issue if you have any feedback or suggestions. We are, of course, completely open to contributions. Thanks for following along with my journey creating Rememberall, and happy building!
Hi, my name is Kenneth Dumas, the Developer Relations Lead here at Graphite, the tool that the fastest developers use to create, review, and merge code. Today we're going to be talking about how we migrated away from Create React App and single-page applications to Next.js. At Graphite, we believe Next.js is the future. For anyone developing scalable, high-performance web applications, you need to migrate away from Create React App and instead move to the Next.js framework. Now, you may hear this and think that sounds challenging, and so did we at first. In migrating our sprawling TypeScript monorepo that dozens of developers collaborate on simultaneously, our first attempts at migration were incredibly long, expensive, and failed partway through. However, after talking to members of the Vercel team and using the new app router, we condensed the entire migration into 5 simple PRs. There are 2 main differences that affected us between Next.js and single-page applications such as those created by React App. The first is rendering and data fetching. Next.js supports multiple rendering strategies, including server-side rendering, SSR, static site generation, SSG, incremental static regeneration, ISR, and client-side rendering, CSR. Depending on the specific page's needs, developers can choose whether to render at compile time, on the server, or in the browser. On the other hand, single-page applications built with Create React App are entirely client-side rendered. The application's content is rendered in the browser using JavaScript. The server sends a nearly empty HTML file, and JavaScript running in the browser fetches data and populates the page. This can increase latency and hurt page responsiveness, as the JavaScript is downloaded, parsed, and executed. Routing. Because of the differences in rendering, the two also differ in how they handle routing. Next.js uses a file system-based router built on App Router. By simply adding files to the Pages directory, routes are automatically available and rendered by the selected strategy. Dynamic routing is also supported by creating files or folders with square bracket notation, like pages/posts bracket id.js, something like that. Create React App, on the other hand, does not provide built-in routing. Instead, developers often integrate libraries like React Router to handle SPA-style navigation, where route changes do not trigger full page reloads, but dynamically change page contents based on the URL. These two differences allow Next.js to optimize performance and improve developer experience in ways that just aren't possible in a traditional single-page application model. The benefits of Next.js over SPAs. Bundle splitting. So this is one of the biggest advantages with Next.js. Traditional single-page applications tend to send a large JavaScript bundle containing the entire application to the browser upon initial request. This can be inefficient, especially for large applications which need to parse and execute this code before first paint. Next.js, however, automatically splits your codebase into smaller JavaScript bundles for each page, meaning that users only load the JavaScript necessary for the current page, greatly improving load times and overall performance. There's other performance improvements too. Along with bundle splitting, Next.js's out-of-the-box optimizations like automatic image optimization and smart prefetching contribute to faster load times and overall user experience. Since Next.js supports both server-side rendering, SSR, and static site generation, it can deliver fully rendered pages to the client, which can significantly improve perceived performance, especially on slower networks. And we're not the only ones who favor Next.js. Search engines also have an opinion. One historical downside of SPAs is the potential for SEO challenges, since not all search engine crawlers execute JavaScript effectively. With Next.js's server rendering capabilities, you deliver fully rendered HTML content to crawlers, ensuring optimal indexing. And it's also just where web development is moving. The web development landscape is rapidly evolving, and new tools and frameworks are emerging all the time. Next.js is the latest in that category, offering increased flexibility, scalability, and performance improvements without adding much overhead. Backed by Vercel, Next has plenty of development resources behind it, while at the same time enjoying the benefits of a strong community and ecosystem. It seamlessly integrates with the Jamstack architecture, which is becoming the go-to for modern web development due to its scalability and performance benefits. More and more developers are moving to Next. So let's take a look at our journey to Next. Knowing the benefits and the differences between the two, we're going to take a look at the 5 pull requests that made that migration possible. The first PR was HTTPS in local development. The first problem we had was an API difference between React scripts, the library CRA uses to power npm start, and Next.js. React scripts has the flag HTTPS equals true to serve content using HTTPS in local development. Unfortunately, Next doesn't have anything analogous, expecting you to use a third-party tool for that. Following a Stack Overflow post, we adopted local SSL proxy. This allowed us to serve local hosts through HTTPS, ensuring that our local development would remain completely unchanged. The next was SVG imports. Create React App has a lot of built-in magic to allow you to import SVGs in JSX. Honestly, it magically supports the import of all sorts of files, but the main one we cared about was SVGs. This was achieved using a specific configuration of the SVGer library, which takes SVGs and converts them into React components. Unfortunately, Next.js doesn't have the same support out of the box. As a solution, in this PR, we imported SVGer and updated to its latest recommended syntax that supports export as both a name component and as a default component. This entailed refactoring a handful of library imports, but overall was a pretty small change. The next was refactoring folder structure. So this one is probably specific to us. As we mentioned above, Next has this awesome built-in routing functionality. Unfortunately, to support this functionality, Next interprets files in the pages directory as routes and assumes they have specific exports. While we did have a pages directory, they were not Next routes and did not have the required exports. This PR just renamed the directory pages to router pages. This next pull request, pun intended, is where the bulk of the migration took place. This is where the magic happens. This pull request included a couple of different changes that I'm going to break out into a few steps. The first thing we had to do was introduce the next config.js file to configure Next. We didn't do anything special with the configuration other than disabling static images. We did this because moving to Next image serving right now would require a pretty big amount of lift. We realized though that we could split this out into an upstream PR later, so for now we turned this off. The next thing we did was tweak our Webpack configuration. All we did here was update Webpack to use the right SVGer version. Furthermore, 2 new files, layout.tsx and page.tsx, were introduced. While layout.tsx replicated the layout previously defined in an index.html and CRA, pages.tsx effectively took over what used to be in the app.js. Development mode. Then, because we're coming from a single-page application, in the Next.js config, we inject a rewrite, which says, hey, for any page loaded, let's just put you right at the index. This allowed us to maintain our client-side routing pattern for the time being. git updates. So here we just updated our git ignore to ignore the next folder, something we didn't have to think about before. And finally, we had to create a bunch of test mocks to handle file imports. You gotta have your tests. These changes enabled us to drop in Next.js. The package.json was updated to replace references of CRA, or in our case, create React app rewired with Next commands. The final PR was to handle server-side rendering, or SSR. Let's take a more in-depth look at the problems that SSR introduces and how we got around them. SSR introduces complexities when accessing objects like window and document. We added conditional checks before accessing objects exclusive to the browser environment. This prevented errors during server-side rendering, where JS might try to access window and run into windows undefined. Additionally, Next renders content on the server for initial render and on the client for updates, and reconciles them through a process called hydration. If these two don't match, Next throws an error. Because React Router does not work on the server, we implemented an initial empty render for both server and client. This was a temporary solution to avoid hydration mismatches that we can remove after we migrate to Next routing. Beyond these primary steps, we also updated our content security policy, or CSP. Next.js injects inline scripts, which are disallowed under our CSP. We resolved this by adding a build step to hash all inline scripts. I hope our little expedition showed you that migration to Next doesn't have to be scary and is well worth it. As we continue our development journey, we plan on fully integrating all the rest of what Next has to offer. Thanks so much for watching. If you liked the talk, you can check out our blog to learn more about Graphite and our journey with Next. If you hated the talk, the same site links to our Slack where you can DM me feedback. Hope to hear from you. Thanks again.
In the next 10 minutes, you're going to learn how to automate all of your customer emails using AI with the help of this koala bear. Here's what the most basic email workflow might look like. Somebody purchases your product, then you send them a login email or a welcome email. That simple situation where you're sending that one email, that one login, or the one email with their receipt can escalate if you want to follow up. If you want to wait a period of time and then send another email. Before you know it, this is your life. This is a reactive, event-driven workflow. We wanted full control. We want access to our data and our database at every single step of the journey. We want to have code level ownership, and this means that all of the code and the driver of our workflow exists in our repositories and that we own that. We want flexibility and ease of use, and this is hugely important because we want to iterate and improve the customer experience over time. We also want to be able to develop and test locally, and as the cherry on top, we want to be able to use generative AI to create some of the content for us. We have absolutely no interest in building, managing, maintaining, or otherwise having to construct a lot of infrastructure to handle our workflows. Instead of owning, operating, building, maintaining, and otherwise having to deal with a ton of infrastructure, we're just going to use ingest. So let's dive into some code and see how we went from this into a working email automation workflow. Inside of our mono repo, we have the lesson completed function. As we scroll through the file, you'll see lesson completed is exported, and this is actually an ingest function. So we're calling ingest.create function, and we pass that a configuration. The second option in our function is the trigger. And in this case, we're triggering the function on the lesson completed event. Finally, we have the function handler, and this is an async function, and it's passed several arguments. In this case, we're using event and step. Event carries context that we're able to pass in. So in this case, we are passing in the user, so we have access to the user ID. And then if you go down a little further, you can see that we're actually passing in data like a lesson sanity ID, so we can look up our lesson module. The step is what actually drives our function. So you'll see right away, the first thing that we're going to do is check and see if this particular user is unsubscribed. So is unsubscribed is an await call to step.run. What's occurring under the hood is that ingest is going to actually call this function, and it's going to call it for each step. So when I call step.run, check if the learner is unsubscribed, I'm able to do some asynchronous work in here. In this case, I'm calling our Redis server and checking for this unsubscribed key. If they're unsubscribed, then it's going to return a value. If we have that value, then we can just return. We're going to quit and opt out of this function altogether. With that little bit of housekeeping taken care of, we're able to continue. And what we want to do is, because our data carries some ID information for the particular lesson that the user just completed, we can take this opportunity to actually load that data. So the event just carried an ID, and now we want to, from our database, load that data. In this case, we're actually loading the lesson metadata from Sanity. And so we call that, and again, it's await step run, get lesson with module. So this calls this function, it awaits it, it returns, and what we have is the lesson with module. We actually get that data back. So we continue down here, and we're going to check and see if that first lesson email has been received. So that gets us into if we can send that email. So here we go. We're actually to the part where we send an email. And in this case, we want to get the user's progress. So we get their overall progress throughout the entire course, right? We're going to use ingest, and we're going to send an event. And what we are doing is requesting that our email get written for us. You can see down here, AI email is the next step. And what this one is doing is actually waiting for an event as a response. Before we take a look at that function that has the steps that generate the actual email text, here are two different ways you can think about this. One, which I'm labeled AI fail here, is you send the event, you ask GPT to generate your email text. You have a single prompt. The AI writer generates the draft from that prompt. The email is complete. And what you end up with is something that's just frankly kind of crappy. Instead, what we're going to do is actually chain a series of prompts where each prompt builds on the last. The AI writer generates a draft that's sent to an editor prompt that is sent back to the AI writer prompt so it can apply those changes. An editor applies final tweaks, and then we actually have a prompt that checks the JSON data structure to make sure it's correct and formatted and will parse. Finally, then the email is complete and you have an email that is perfectly acceptable. So here's what this actually looks like in code, right? So we send out the email writing request event, and that triggers this function. So this looks very similar, right? Like we have the export write an email ingest create function. We have that configuration. We have the trigger. We get our event and our step. In this case, we sent some progress along because we want to take that progress data and use that as input for our prompt. So we break that apart and build some structured data because you pay by the token when you send to OpenAI's APIs. So we're just trying to reduce that a little bit. And we do that by just parsing the data. So we get that data in, we parse it, we put it in a structured format, and then we write a system prompt. So our system prompt is just kind of telling GPT what it is we want it to do. Now we have the writer prompt, and in this case, we tell the GPT that Cody the koala is who you are, and you have this lovely koala that you like to sign your emails with. We define the task, we define the motivation, we have important considerations, and with our first step, we are waiting for an AI response. So we call step run, send to writer for first draft. This simply calls OpenAI APIs and uses the chat completions API to create our first part of the conversation. We have the system prompt up here, and then we have this first user prompt that we passed in. So once that response is returned, we're going to move down to our editor prompt. And again, we are going to wait for a response. So we get to our next step. This step runs. Each one of these is executed as an individual function call. So in this case, we're deployed to Vercel. So when this step runs, this is an individual function call. Ingest takes all of these steps inside of the function and then calls as needed to execute them. So each one is an individual function call. You're not waiting for this entire thing to process. You're waiting for this single step to process. So here we go. Same thing. We get the response back. We take the AI writer's revision, give them a new prompt, and at each step of the way, we're including each of the previous prompts and responses. And finally, we get down here, we send an event notifying that the writing is done, and this is where our email writing request completed event happens. So back inside of our lesson completed function, now that we've received the email writing request completed event, we can proceed. So when we come back over, we have this data that comes back with the event in an asynchronous way. So it's awaiting this. It doesn't proceed until this event occurs. So we come down here and we're able to get the options for this particular email. And in the next step, we're going to send the first lesson of the module completed email. This calls the send email function. Behind the scenes, we're using React Email, which is very nice. Here I am inside of the actual workshop on a lesson, and I'm going to go ahead and mark it as complete. All right, so inside of the dev server, we see that our events were received. So lesson completed was received. It's in progress. If we come down here, we can see that it's waiting for the email completed event. And if we come into our GPT-4 email writer, we can see that these steps have started to execute. So send to writer for first draft. And we've already got one response back, and there we go. Kudos, Joel. You're making progress. It really loves to put this koala emoji everywhere. And you can see it just builds this text out. We send it to the editor for suggestions. They bring that back to us. And this proceeds until the events have completed and the process is done. So here is the actual email that it sent me. It came up with an extremely reasonable email. You can expand this workflow. You can expand the number of events that are handled. You can use this process iteratively to build an entire communication stack that you fully own and control inside of your code base, and workflows that are endless, processes that you haven't even thought of yet. You're going to be able to create them in a way that allows you to focus on the interactions and the work at hand instead of maintaining all of that infrastructure.
Hi everyone, my name is Sandeep and I'm the co-founder of Hashnode. I'm so excited to speak at NextConf this year. We have been using Vercel for more than 2 years now, and we have been super early adopters of their platform-specific features. In this talk, I'm going to talk about how exactly we use Vercel to scale past 10,000 plus custom domains at Hashnode. In case you're not aware of what Hashnode is the best platform for developers to start a blog on their own domain under a minute or so and take control of their data. If we are taking Hashnode at a glance, we recently crossed 10 million monthly views, 100 million views since inception, and running 10K plus custom domains, and more than 3 million monthly unique reads so far. But this poses a unique engineering challenge. See, Hashnode's core belief is that every developer or every Hashnode user should be able to map a custom domain for free, which means we need to serve all of these custom domains over HTTPS. Let's take a look at all the options that we evaluated and ultimately settled on Vercel. Honestly, before even looking at solution 1, we briefly tried to do this on AWS, but AWS has a lot of limitations on how many custom domains you can add per CloudFront distribution, because that's what we wanted to use as a CDN. But eventually it didn't work out, and we started looking for more alternatives. The first solution that came to our mind was that we create multiple DigitalOcean droplets in different regions, and then we use AWS Route 53 to geographically route the request to the nearest data center. And each of these DigitalOcean droplets will have something called OpenResty, which is an extended version of Nginx, and it also uses Lua. So this Lua Resty Auto SSL plugin, it helps generate SSL certificates for arbitrary custom domains on the fly. And under the hood, it uses Let's Encrypt, and it also has a Redis adapter. So which means we can have 4 or 5 instances that run Lua Resty Auto SSL plugin, and then we give it a Redis instance, and that's where it generates and caches the SSL certificates. So together with this multiple droplets on DigitalOcean and multiple Redis instances to store these SSL certificates, we created sort of a DIY solution to create a homegrown CDN. By the way, this was super early in Hashnode's history. I think more than 3 years back, just when we were starting to offer this custom domain offering. So this worked out well, but it had a lot of maintenance work, right? We had to, since we own the infrastructure, we have to maintain it. And we also need to worry about a lot of things like DDoS attacks and performance, adding more edge nodes so that we can have better performance and more and better TTFB value across the world. And we also saw a lot of random failures which were hard to debug, and that would take a lot of our time. And eventually we started looking for a different alternative, and we were not really 100% happy with how LuaRST or SSL was working. So after that, we started evaluating Caddy. Still a big fan of Caddy, and the best part of Caddy is that it automatically supports HTTPS out of the box. And if you can give it any arbitrary custom domain, and as long as the configuration, the DNS configuration is right, it can generate SSL certificates using Let's Encrypt. And another point that is worth mentioning is that Caddy supports something called flip mode, which means if you can create multiple Caddy instances and somehow make them use the same underlying storage layer, it can issue SSL certificates, and you can manage them among all of these nodes automatically without you having to do anything yourself. So this also worked really well, and we in fact ran this whole Caddy based setup for more than I think a year. But again, we have always been thinking that we don't want to manage anything that is not core to our business, because we want to spend a lot of time solving our core business problems and not worry about SSL certificates, for example. So, and we also saw a lot of random failures at some points, which were again taking a lot of our time and resources, and we wanted to find a better alternative. Now enter Vercel. Once we realized that Vercel offers an API-based solution that lets you manage custom domains, we instantly bit the bullet. It was a no-brainer for us. After all, we didn't want to manage anything, so we could probably outsource everything to Vercel and focus on our core parts of the business. So the way it works is that Vercel makes it really easy to manage custom domains in 3 simple steps. First, every time a Hashnode user maps a custom domain, we make an API call to Vercel, and we use their V8 projects and domains endpoint to assign that to a particular project on Vercel. And we then ask our users to add a CNAME record on their DNS, which basically points to Vercel's Anycast IP. And Vercel also offers a config endpoint, which tells you whether that particular domain is properly set up or not. And if it returns misconfigured false, it means it's set up correctly and it's ready to use. SSL certificate has been issued, and the best part is that Vercel is going to manage the certificates and keep renewing it every 90 days. For us, that's the best thing, right? We don't have to manage anything. We don't have to worry about anything. We just let Vercel do its magic. In the initial days, it was slightly more difficult to add more than 500 domains on Vercel, because at that time Vercel used to have 500 domains restriction per project. So the solution was that we add these domains on an account level than a project level, and we create aliases and we remove them manually through API calls. But of course, as you know, Vercel eventually made it super easy, and right now you can basically manage custom domains using 3 simple steps. But one thing that we do slightly differently is that we maintain 2 separate projects to manage the custom domains, because since we manage 10K plus custom domains, every time we deploy, it takes a bit of a time to move these custom domains from one deployment to a different one, right? So, and this also poses a bit of a challenge if we roll back. So the current solution is that we maintain two separate projects. One which doesn't see a lot of deployments, it just sees deployments once in a while, and its primary job is to reverse proxy to the actual blog front end that is hosted on Vercel. This is how it looks like. We have a simple rewrite on vercel.json, which takes the host name into account, and it internally does the rewrite and proxies to the actual blog frontend project. Since we don't do any deployments to this project, we don't have to worry about moving these domains from one deployment to the other one. And we can also manage a lot of domains this way. I would like to take a moment to show you how this works in practice. So just go to your Hashnode blog dashboard, head over to the custom domain tab and enter your domain. For me, it is test.sandeep.dev. Hit update. And this is where we make the API call to Vercel. And I'll just go ahead and update my DNS settings. So I'll add a new record and I'll say that, okay, CNAME is test and the value is hashnode.network, which again resolves to Vercel. I'll be sure to turn this off and I'll save it. And I'll go back to Vercel and it's done. As you can see, it's live. So one of the core beliefs at Hashnode is that we don't want to manage anything that is not core to our business. So by using Vercel's domain API, we outsource the entire domain management to Vercel. We let them upkeep the burden. We let them focus on performance, DDoS protection, and so many other things that we don't want to do. And this way we can reclaim our time and we can use that to make Hashnode a better plugin platform. So yeah, we're getting a lot of value out of Vercel, and I encourage anyone who wants to start a platform business to look at Vercel's domain management APIs. We constantly write about how we manage our infrastructure at our engineering blog, engineering.hashnode.com. Feel free to read it, and if you have any other questions regarding Hashnode in general or any other infrastructure questions, feel free to reach out to us. Thank you so much.